Okay, so first of all, good afternoon, everyone, and very welcome. I'm so happy to see many people here. And as a matter of fact, the meeting today is the starting of something new because we want to go ahead with this project, but also is the final point of 1 year of activity of some working groups. Who the people will present later on, the chairs of the working group will present later on what they did. I want just to tell you where this adventure started. And I have to say that, as a matter of fact, everything started from an initiative that is called UN OpenGIS, which is an initiative for building an open source geospatial, not only GIS, but much more geospatial ecosystem for United Nations based on open source. And specifically in this initiative, and then Professor Ki-Jun Lee from UN OpenGIS will tell you something more about that. There is this working group 5, which is about GeoAI. So if you are interested, obviously, you can start collaborating also with this initiative. You see here the 3 chairs of this working group. So myself and then Andrea Manara. You see Andrea Manara will also present later on from the ITU. And Zhongxin Chen, who is not here, is from FAO. Then we have another place where we were discussing all these topics, which is the UN-GGIM academic network. UN-GGIM will be presented later on by Paloma Merodio. And then in this initiative, which is something we are doing for UN, as a matter of fact, there is also a network of universities. And okay, I happen to be the chair of this network, and we started discussing about the GeoAI. And in this discussion, we also had the possibility of eliciting the participation of other networks of UN-GGIM, specifically the UN-GGIM Geospatial Network, and which is the network of the UN agencies, of the 40 UN agencies, with the people working on geospatial information. And in this network, Andrea is representing GeoAI. Then there is the UN-GGIM private sector. And unfortunately, today, the chair was not able to come. But then the last network is the network of UN-GGIM Geospatial Society. And Celine Rosenblatt is here, Professor Rosenblatt is here, and she will present also, say something quickly about the network. But let's go and see what we are doing. There is this series within the initiatives of AI for Good, which is called GeoAI. And within this series, we are doing many activities. I will present the workshops activities, webinars, and every lectures and everything related to GeoAI. We started doing these events in 2021, 2022. In the beginning, there were also Nadine Alamé and Barbara Ryan. If you don't know them, at that time, Nadine was the director of the OGC, and Barbara was the director of the World Geospatial Industrial Council. Now they change roles and they are no more involved also in this initiative. But then Andrea was always part of the initiative. I have to say that he is the initiative as a matter of fact. He is behind everything. And then starting from this year, we have also Rohini helping us in the organization of these events. Rohini is from UNICEF. Now I'm telling you something about this activity. Please, if you are interested in collaborating in every way, please contact us. We organized, as I said, many webinars. You can go to AI for Good and search for the series of webinars that were organized. I'm just quickly showing you some of them. And I have to say that these were the last webinars. You see that there was one in June last year about the GeoAI education. And then there was this one, the 5th of July, which was the beginning of this adventure. As a matter of fact, was something similar to the one of today, where we start discussing about how to build a foundation for geospatial AI. So discussing about, at that time, we were thinking syllabus one, but during the discussion, we decided that we needed much more. And so you see here all the webinars that were organized in 2021, 2023. And again, this one again. And what is interesting is that some of these workshops are very well attended. So you see, for instance, in this case, was a workshop about using machine learning with QGIS for analyzing satellite data. And it was attended by 1,300 people. So very, very good attendance. And you see also later on, it was very well welcomed, this kind of webinar. So generally, what we discover is that people needed to have some webinars, workshops for learn how to use tools for doing machine learning. Then another interesting point are these surveys that we did at two different levels. This was something that was done as a UNGGM academic network. And so we proposed a survey to the members of the network and also to the member states of UNGGIM. As I told you, then Dr. Merodio will tell you something more about that. And with respect to this survey, it's interesting that we asked too many questions, but I'm just putting the most important two. So this is on a scale from 0 to 5. How do you think do you evaluate the introduction of GeoAI as a new subject in your university? And as you see, there was a good consensus about it. Yeah, it's the right time for introducing GeoAI as a new subject in your university. Then it was a bit strange, but another question was, what are thinking your students about introducing GeoAI as a new subject at your university? And the strange point is, at least for me, that many answers, I don't know. I have no idea about what students are thinking. But you see that there was a certain consensus about, yes, my students want me to teach something about GeoAI. I have to say that I'm teaching at the Politecnico di Milano, and our students are asking us definitely to introduce also this new subject. In fact, we are introducing it starting from the next academic year. Okay, but these other surveys, a survey with the member states of UNGGIM. Also here, many questions. If you're interested, obviously you can write me. I will send you the results of the surveys. Anyway, one question is, how do you evaluate the introduction of GeoAI as a new subject in universities? And again, at the level of member states, they say no, that is relevant. It's important for the young people. Okay, so starting from this, we organized last year at the UNGGIM side event about opportunities and challenges related to GeoAI, which was some way in continuation with respect to what we started here. And what we started here was, this was the previous workshop here in July last year with the people there discussing about the syllabus. And we started thinking a syllabus, but as I told you, then in the discussion, it emerged that a syllabus was not enough because there are different typologies of users, let us call them users. And then we decided that it was really important to define a syllabus for developers. Developers meaning people who are from who are more expert in computer science, computer technologies, but they know nothing about geospatial application and geospatial science. Then a second syllabus for appliers. When we say appliers, we mean people who are expert in geospatial information, but they are not so expert in ICT. But then the third level is also very interesting and is a syllabus for decision makers, because also decision makers in the geospatial domain, they need to understand what is possible to do and what is not possible to do using AI in such a way to better tune their expectation also with respect to what they can ask to technicians and what way they can obtain using GeoAI. Okay, and the last thing, which is more or less a glue between all these these three syllabi, is the body of knowledge. So building the body of knowledge on geospatial AI in such a way to have common knowledge, to be able to understand perfectly when we use certain names, certain terms, what we are speaking about. Okay, so this was the workshop of last year, and you will see the result of the activity of this year. Speaking about webinars, because we go ahead also with webinars, we decided mainly discussing with Rohini and Andrea this year, the last year, to focus more on foundation models. It means that we didn't consider only foundation models, but our idea was to put more attention on foundation models because it's something new emerging. And so we organized these webinars. You see here, like this was in general about the definition of generative AI foundation models and also some applications in the geospatial domain. This was specific on an interesting foundation model, which is the one developed by IBM and NASA together, using as a basic data set the harmonized Landsat CSAT images. So if you are interested, everything is available online, so you can find the slides, you can find the video, everything online. And then there is the last webinar before summer that will be on 26th of June, and it's about, this one also about large language model, and it will be presented better by Tiziana later on. Okay, the last thing that I want to mention to you is that we have also a special issue of the ITU journal. And therefore, if you are interested in contributing to this special issue, you are very welcome. I have to say that it is very well received by the UN agencies. So it's something that has a good diffusion in the UN agencies. And so if you are interested in contributing, you are very welcome. You see there is the call for papers. Please apply for that. And okay, so say that, I think that we can start with our presentation. And okay, so I will call the first presenter.
agenda?
Yeah, sure. Sorry. Yes. So those are the people I will put the agenda. Yeah, it's two. Okay, so there is my short presentation here, and then we have the presentation of working group 1 by Andrea Nascetti. So AI for good for developers. Then the second presenter is Ali Mansouria from Lund University. Working group 2 is AI for good for appliers. Then we have the third presenter with Parvati Krishna Kumari. Your surname is very complicated for me. And from Amsterdam Uni, who will present on the opposite what is the syllabus for decision makers. Then we have Celine Rosenblatt. Oh, sorry, I forgot to say professor to everyone. All of them are professors from the University of Lausanne, and she will present on the opposite the activity that was done on the body of knowledge. And then we will have the break. After the break, so the first part is for presenting the activity that we have done this year. But after the break, we want to have some comments by you. So I cannot really say external actors because in some way they are interacting with us. So Dr. Merodio from INEHI and also UNGGIM, Andrea Manara as ITU and UN Geospatial Network and AI for Good. And then we have also something related to the challenges because Andrea will present the challenges. And so Paul Kennedy from Zindi, which is a platform that is used for challenges, and Stella Ofori Ampofo, but I don't want to say now. With Stella, we will discover later on. Then we have Kijun Lee, Professor Kijun Lee from Busan University, who is one of the chair of the UN OpenGIS. So he will tell the importance of these activities for the UN OpenGIS. Then Celine again, because she's also the chair of the UN GGIM Geospatial Society. And then we have UN ESCAP, Tiziana Bonapace, presenting what they are doing. From GEO, we have Dr. Chu, Wenbo Chu. She's already here. I saw her before. Yes, she's there. Okay, and then we wanted also to have to give the word to young people, so to students. And so we have Yogender representing the student consortium of ISPRS, because we are working with them and for them. And so we wanted to understand also if we are doing well or not, or what we have to check. And then if everyone stays in the time that was fixed, we have also some time for discussing and just a very quick conclusion. And we can close here, deciding also how to go ahead. I want to finish this meeting with some ideas about how we can go ahead. Okay, so thank you. And at this point, I will give very quickly the word to Andrea. So working group 1, the syllabus for developers.
Slides. Yes, it's working. Okay. Thank you, Maria, for the introduction, also for the introduction of our work. It's a real pleasure for me to be here and present the work that we have done in the last year together with working group 1, with my colleague Fabrice and Adam were leading this activity, and we try to understand how we can develop a new course, a syllabus on geospatial AI for development. that was the main goal of our activity. So we have this aim to have a course specifically designed to understand how we can use modern AI algorithms that are one of the hot topic of the entire conference here to analyze geospatial data. And now we can use this algorithm in the geospatial context, understanding the limitation of these algorithms and what are the pros and cons of using them. Now we are almost everyone is using this algorithm, but we believe that we have to build a more deep knowledge to understand the limitation of also of this algorithm. So the course would focus on understanding the machine learning and deep learning algorithm for geospatial analysis. And the goal is to equip the students with a background to apply this algorithm and implement the pipelines to process large-scale data and be able to analyze the results, adapt the results to new scenarios and new applications. And it will be a course based on coding. So what we are assuming is that all the students with attending this course, they have a good coding skills. So we are not going to teach the students how to code. We are assuming that all the students here are able to code in Python. So they will have done some courses in the previous studies, so they are good coders. That's the background that that is the required background to enter in this course. And why Python? That was one of the questions during our discussion, because today it's the most common used language. It's not the only one. There are alternative programming language, but we think Python is still a standard, an industrial standard also today. So they will have a hands-on experience on Python and developing script and coding to analyze data. So how we organize this course is in a course in 6 modules. I have to look here. Okay. Yeah. It's very weird because I like to look at the screen, but okay, I will look here in my face. Sorry. Yes, I know. Sorry. Okay, so I will look here. So then can you see? Don't yeah, look here. Okay. No, sorry. So we organize the course in 6 modules. So as you see, we have 2 optional modules at the beginning. So the first module is an introduction to remote sensing GIS, because we are assuming that part of the students that will take this course have no background in remote sensing and GIS, so they need an introduction, at least 3 CFU of introduction for this course. Then we have a second module that is where we call it a refresher of machine learning models. Might students have already a background of machine learning, so they might not need this module. So that's why it's an optional module. If they want to have a refresh on a machine learning model, they can follow this module. Otherwise, they can just jump in the other 4 modules that are the main core of the course. So the first one, it's a module that we call geodata processing. So it's how we handle geospatial information from using coding. And the 4th module is how we can apply machine learning for specific geospatial analysis. And then we have an advanced model of machine learning with the, let me say, the state-of-art algorithm for analyzing geobig data. And then the final module is the final project course, where they have to develop the final project also for grading. So as I discussed before, the prerequisites are a solid background in programming. So that's something that they have to have before starting the course. And a good knowledge in machine learning and deep learning is helpful unless they can do this refresher, the second module. But they can start the course with no general knowledge of geospatial data, and everything should be enough to build this knowledge on how to analyze geospatial data. Here we have the intended learning outcomes. So it's a very dense text slide. So the main goal is to build this knowledge of analyzing the AI algorithm, understanding all the challenges on developing this algorithm, especially the geospatial challenges. One of them personally that I can list as example is the transferability of this model. We have a lot of models trained in some region, in some area, or in some specific time frame that are not easily adaptable to another time. So the students should learn how the models are trained, what are the limitations of the training data, how to apply this model to unseen data and unseen scenario. And they have to start to build some competencies and skill on how to prepare the data for training this model. So how can they collect the data, put the data in a right format, and be able to feed the data in a machine learning or deep learning model. And then one of the most important part is to judge and assess the model. This model can be trained, are very powerful. They can produce interesting results, but they can also produce unreliable results. Sometimes we call it black model for a reason, because in some way they are black model. Now there is a lot of research on explaining this model, but the students should learn what are the limitations of this black model, not just using it without understanding the limitation. So these are more or less the summary of the learning outcomes. And now I will go through the module just to give you an idea what they are going to study during the course. So the first module is the introduction to remote sensing and GIS. And I put this picture here that is a real representation of the number of satellites that is orbiting the Earth. I read a recent study that in 2030, we will have 57,000 satellites orbiting the Earth. Just to remember us the amount of data that is coming from space. It's not only Earth observation satellite, but a big percentage of this satellite is Earth observation. So we have data. We have data coming from satellite, we have data coming from airplane, drones, IoT station. We have a lot of geospatial data. So we have to introduce the students what are the format, the type of data that we can collect, the different modalities from optical data, multispectral, hyperspectral, SAR. They should have an understanding of the differences of the modality and how they are collected. So we were going to introduce this in the first module, and some popular sensor like Sentinel constellation, Landsat, the most popular satellite constellation. And we should pay a bit of attention also on coordinate system, projection and transformation. The data are acquired not always in the same coordinate system, and sometimes one of the struggling for, especially for students that have no background in GIS, is how to merge them. They are acquiring a lot of data, but these are not co-registered, they're not in the right place, not correctly co-registered. So this is the first module. The second module is this refresher of machine learning. So this can be considered as a small recap on the standard machine learning algorithm. So from supervised to unsupervised training, and regular traditional algorithm like random forest, gradient boosted, and so on, just to remember the students how this algorithm works in case they need it. And then we want to pay a bit of attention how we can assess this model with standard technique like link one out or k-fold cross-validation. And then introducing quickly, so this is not a theoretical course of deep learning. So this course is to empower the student to use the model. So we will have a introduction of deep learning and CNN, so convolutional neural network, to be able to understand the model that they're going to use later on without going on the mathematical details, because otherwise it's a couple of other courses just to dig into all the math behind these models. And the third model that it's, in my opinion, also is a very important model for the students is how to handle all these different data, this geospatial data. So the first core of the model is to understand the data model, so the geospatial data model, especially what we sometimes call data cubes, and this new popular format that now is called X-array. It's a format that can handle different data, different geographical data representation in a data cube. So the students have to understand how we can represent this data in a smart way, so then we can access them and we can feed the data into the models. They have to learn how they can collect this data from which platform, especially cloud platform like Earth Engine, the NASA Earth API, Copernicus, and so on. So they need to have access to the API to collect the data. How to merge this data also with other sources like ground station and so on. And in general, think about how we can design what we call a sampling strategy. In this image here, you see I just randomly sample the earth with some patches. So this process of sampling the earth is affecting how the model will perform. So we have to think about sampling strategy that can work spatially and temporally for the application that we have in mind. So we're going to reflect to how they develop and design a sampling strategy. The fourth model, it's a machine learning for geospatial analysis. So it's a model where they start to use more traditional machine learning algorithm for analyzing satellite and series and geospatial data. So let's say random forests and gradient boosting algorithm. Here is an example of maybe classifying urban area. This is Rome, my hometown. So I put some like nostalgia of my home here. And so they will learn how to classify buildings, how to perform land cover mapping and so on. So it's traditional machine learning approach with a focus on evaluating the limitation of the model they use, especially understanding the cross-regional assessment of the model. And then we have the fifth model, that is the most advanced model. So here we are going to discuss something that Maria introduced in the last webinar. So the use of foundation model for geospatial data analysis. So how these foundation models are designed, the concept of self-supervised training, how we can develop autoencoder and variational autoencoder model, and more advanced architecture like Fission transformer. So this is like the most advanced model from the model point of view. Here in this example, I put an example of a super resolution of Sentinel-2. This is Geneva. So this is the old, this is the original resolution of Sentinel-2. This is what you can get with a diffusion model. So improving the resolution of the data. There is some debate here on what is possible to do, but the students can learn how to train a diffusion model for super resolution. And here also how to merge different modality, how we can take data from radar, from LiDAR, from multispectral, and feed the data in the same model to extract the representation feature. So here is some way the core of the advanced model. And then the students at the end, they have to do some project. So, and here we come up with two possible solutions. So the first solution is a kind of most traditional student project where they have to implement a pipeline for analyzing probably large scale data, or at least like a decent amount of data, not a small patch of data, and use some of the existing algorithm online. Here I made an example. This is segment anything model applied for geospatial data. So you can see here they took the model developed by Meta AI from Facebook, they adapted for geospatial data, and they're able to easily segment an aerial image in this case. So the students in the first option, they have to come up with some proposal on taking some algorithm of the state of the art, test the algorithm, adapt it to the study area that they want to investigate, and implement the full pipeline. Then the second option that is a bit more unconventional, let me say. So it's a data challenge. So we are thinking that at the end of the course, we can run a small data challenge. The students can group together in small groups, join the data challenge, and all together they are going to work on the same data set. And they're going to perform, test different architecture, different methodology that they have in some way developed learned during the course to solve the problem of the data challenge. The application can be, let me say, any relevant application for geospatial data analysis. So I think this is more or less the structure of the course. Yeah, I thank you for the attention.
Okay, so thank you, Anastasia, because we have you were very good.
Yeah.
So you finish 2 minutes before.
You see?
So if there is one question, only one question, if not, yes, I see that there is one question from the floor.
I'm allowed.
Yes.
All right. So this is just a quick question. So I think
Speak loud in such a way.
so this is very quick question.
Yeah.
So it is very well designed. I appreciate it. So could you tell me the number of weeks for each module?
For each models,
So number of hours or number of weeks or?
we have it in, now I don't remember by heart exactly what we discussed. So I have it in the document. I didn't put it here, but it's the total amount of credit of university credit, at least as we counted in the European, I think.
Yes.
It's 15 credits. So it's
15.
almost two full courses. So it could be, depends on the university.
15
1 full
credits
Yeah.
is more or less under 50 hours in class.
50 hours.
No, 15 credits
think
is
depends on the
under
university.
50 hours in class,
Oh.
more or less, more or less. Then it depends on the university, it depends on the country, but
At KTH, for instance, that we have courses that are split in 3 months. So we have no semester, but we have like 4 period. This could be an activity that is going to 2 period. So one course in period 1 and another course in period 2, for instance. So it's a 6 months half-time work for a
Alright.
student. That's more or less what we have told you was
All
reasonable.
right. So 15 credit for the whole module.
Yes, for all the models, yeah.
but then we have the syllabus. And
Yes,
so
I
we
can
will
share.
share the syllabus after that, not only the slides, but we can share on
Yeah,
the
the document, yeah.
website also the syllabus as it was prepared.
And it is for graduate student or
It's for,
it is the
Graduate.
master student?
yeah, it's for master students. Yeah.
So will the course be made like available as online course? So that's accessible by many more students?
This is something we have to decide because, as I said, the first year was devoted to building the syllabi. And now we have to start deciding how to go ahead. So how to really build the courses, which requires much more energy, much more people and the support. But yeah, in the end, so our dream is to make available these courses as free of charge and open for everyone. This is our dream. Let us see if we are able of doing that. And obviously, if you have ideas of if you want to contribute, you are very welcome.
Yeah, you're welcome for any suggestion also to improve it. So it's an ongoing work.
Okay.
Right. Yeah.
Thank you, Andrea. Okay, so now in such a way that they see me. So now we go to the second syllabus, which is the syllabus for appliers. So expert in GIS.
So,
No.
I will sit. Take it easy. My experience shows that if there is a lecture after lunch, audiences get bored immediately after half an hour. No, that time has passed. So while I load my PowerPoint, I may suggest that you stand up, stretch the legs a little, get fresh.
Thank you.
Good idea. You see, they're leaving.
Join your.
There was, if you would have arrived on
Anyway, thank you, and then thank you all the team working on the working group one. Yes. Is that because everyone is using us?
How is it? This is Sean. Very good. So, good afternoon, everyone. My name is Ali Mansourian. I'm a professor of geomatics at Lund University, Sweden. I'm also director of GIS Center and coordinator of GIS and Remote Sensing Master Program at the same university. As Maria said, I'm going to present the course syllabus that we have developed for appliers. And this work has been done with the cooperation of prestigious, knowledgeable, and skillful professors and experts from all around the world that you can see their names here. And it's very nice that some of them are already in this meeting. We have Eric, we have Celine, we have Ludvigo. So if there is any error in the syllabus, you can blame them. Just presenting. But anyway, actually, in order to develop this syllabus, actually, we followed the workflow that you can see here. We started with identifying the target groups or define who are the students who are going to study the course. Then we define the aim of the course. We define the learning outcomes. We actually came up with the prerequisites for the course. And then we defined the modules. And after that, actually, we use a recursive approach to actually improve the learning outcomes and actually make sure that everything fit together well. So I try to explain actually these 5 steps one by one. About the target groups, we were inspired by what Maria presented before. Our target groups are GIS and remote sensing experts in public and private organizations who are working with GIS and remote sensing for planning and decision-making in different disciplines, and then they would like to use artificial intelligence to improve the quality of analyses and processes. And they have fair background knowledge of mathematics and statistics, we assume. And also they have some basic programming skills. Based on these, we defined the needs of the students. So they need to learn AI algorithms, of course. They need to learn about applications of AI algorithms in GIS and remote sensing. And they need dedicated knowledge about GeoAI algorithms for spatial and spatial temporal modeling and analysis. Also, they need to learn about ethical aspects and governance of GeoAI, which was also very important and discussed in the plenary session of the conference. So we try to actually respond to these needs when we define the syllabus. The aim of the course we defined as to provide the students or appliers in this case with the required knowledge and skills to use GeoAI in their GIS and remote sensing projects to improve the quality and reliability of analysis. For learning outcomes, we define learning outcomes in 3 categories, as also Andre presented: knowledge and understanding, competence and skills, judgment and evaluation. We selected these 3 categories to make sure that we can cover all levels of learning according to the Bloom's taxonomy. So by studying this course, we expect that students not only understand and remember the concepts, but also they are problem solvers and they can actually apply them in different applications and be creators. So for each category, we define some bullet points as learning outcomes. For example, in terms of knowledge and understanding, we expect students to understand classical methods and algorithms, to understand and explain major AI algorithms for optimization and machine learning, to understand and explain GeoAI trends such as generative AI, which is a trend of today. It will change indeed in the future, and also to understand and explain main items related to GeoAI governance. In terms of competence and skills, they should be able to implement and apply the techniques. So they need to be able to formulate the geospatial problem and explore the appropriate GeoAI algorithm.
to use and apply AI algorithms, software libraries, and tools for geospatial analysis, to design and develop GeoAI functions, and make methods fit better to geospatial applications, and to implement ethical principles and actually concepts in GeoAI projects. And related to judgment and evaluation, we want them to explore suitable algorithms and construct proper workflow for right applications to assess the accuracy and reliability of the results and the goodness of fit, and to evaluate the selected based strategies for implementing ethical principles and governance of GeoAI. So as you can see, we have actually tried to cover all aspects. About prerequisites, we assume that students who are going to study this course has a background knowledge and a skill in GIS equal to 15 ECTS in each. And I have also defined ECTS in another slide. We also want them to have a good background knowledge of mathematics and statistics and some basic programming skills to be able to do the exercises which have been designed for the GeoAI course. Then we designed the course in 6 modules, actually. The first module is the basic module, as I will explain. It's mainly about basic statistics and mathematical functions behind AI and GeoAI. We have one module focusing on optimization, another module focusing on machine learning. When students gain a good knowledge about these principal machine learning algorithms, then we have one module about geospatial machine learning, how it will be applied in GIS remote sensing applications, one module about generative AI. As I said, that's the trend of today. More modules may be needed to be designed in the future, and also one module about AI governance and ethics. To actually define each module, we used a tabular format, as you can see here. In this table, for each module, we define the related topics, different topics that need to be taught for that module. And then for each topic, we detail the learning outcomes, what students are expected to be to learn by studying this topic. It will be very useful for course organizers in the future to understand what is this topic about and how they need to design the course based on that. And then we have a type for the topic. If this topic is going to be offered as a lecture or as an exercise or lab work, it should be a seminar that students do a work and then present in the classroom. It should be based on a discussion. For example, a group will work in the classroom, or it should be as a project. So we also specified it, and also ECTS, the number of credits for each topic. ECTS is European Credit Transfer System. That's a European standard, which is not followed as an standard by European universities. So it's a strange standard, which is not followed. In Sweden, we say that 1 week work, full-time work by a student, it's equal to 40 hours and it's 1.5 credits. But I know that in Italy, it's defined another way. And that's why it's non-standard standard. Yeah, but the standard that we used in this actually syllabus is that 1 ECTS is 1.5 credits is equal to 1 week work, full-time work by the student. And it is not the time that teacher spends to teach. That is the time that the student spends to learn. So this is how the modules look like, actually. The first module, which is about basics, as you can see, we have the topic, and then we have defined the learning outcomes. I don't go into the details. We have also the type of the topic. For example, for the first one, which is fundamentals of algebra and statistics, it will be taught as a lecture and also based on designed lab works and exercises. And it's equal to half ECTS. That's 20 hours work for students. So we have designed the topics for the first module, and then for the second module, which is optimization. You know that there are different optimization algorithms available in the literature. So we decided that we teach students about genetic algorithm as a single objective optimization technique, both lecture and exercise. multi-objective optimization based on NSGA2, also as a lecture and exercise. And then we have one lecture to introduce different other algorithms from, for example, swarm intelligence, thus just to make students familiar with available algorithms that can be used and applied in different areas. And that is equal to 10 hours work for the students. The third module, which is machine learning, we start with basic actually concepts for training a machine learning algorithm, how a machine is trained. And then we introduce techniques such as decision trees, support vector machine, but we'll focus on artificial neural network, deep learning, which is popular these days. There are different deep learning models. We thought that maybe CNN is the one which might be more useful and interesting for students. And then ensemble learning, hyperparameter tuning. But we also designed a seminar that students can study about different deep learning models and then present them in the classroom to the other students. And also one topic about bias and fairness. The fourth module is about geographical machine learning. So while a student has knowledge about machine learning, then they can study geospatial machine learning. How you can use, for example, geographic machine learning to study heterogeneities, to do heterogeneity analysis, multi-scale machine learning, to actually analyze spatial data or maps with multi-scales, graph neural network, which is applied on network type data for analysis, and deep learning for spatiotemporal analysis. And something interesting in this module is that we designed several actually use cases that as projects that can be implemented by the students. So they can have use cases related to agriculture and food, related to land use classification, spatial epidemiology and health, transportation, climate change, sustainability, renewable energy, and we kept it open actually. Course organizers, depending on the need of the students, they can define interesting use cases where geospatial artificial intelligence can be used actually to solve a problem in that area. Then we have the fifth module about generative AI. We have designed the basic concepts which are related to generative AI to be studied by the students, and some concept related to GeoAI, as you can see here, and they have been listed. And also one module about AI governance and ethics. This module actually includes topics that review existing policies or under development policies. For example, the policies that are recently approved by European Commission. It could be something that can be taught to the students in this course, how they can be implemented in GeoAI projects by project leaders, and also how they can be implemented and how they can be used. And that is the main aim of this module. We have also introduced some bibliographies, references that can be used by the students, and IT tools and libraries which can be used for implementation of this course. And all of the tools that we have selected are open source indeed. Something interesting is how to study this course. What we have designed so far is equal to 26 ECTS. So it's a very big course. When we were designing this course from the beginning, our idea was that we created different pieces of puzzle. And then course organizers, depending on their needs, they can pick the topics which are of their interest, put them together, and create the course that they want. So for example, one organization which is working with agriculture, maybe they think that they don't need optimization. The experts know already about basic of statistics, so they can use only the topics related to machine learning, geospatial machine learning, and create the course that they want. So that is why we have defined learning outcomes for each topic individually, that actually the course can be designed by course organizer. So it's a very flexible syllabus that we have actually defined in this book. That's all. Thank you very much for your attention. If you have questions or comments, I would be happy
There is
to answer.
time, there is time, because
but
you're very.
I was very fast.
Yes, you were very fast, and so if you have questions, For working group 2, I see Kijun has a question.
Sorry to ask so many questions. So I think it is wonderful, but some of the topics that you designed, also you are just a representative. So anyway,
They have designed.
so some of the topics that you designed could be included in the first part. So there are maybe some overlapping. For example, so at the end of the program, you may have not a separate project, but you may make a one single team composed of this one and that one. So that could be some kind of complement. And
Yeah, indeed. I can say that there is an overlap, some sort of overlap between
Yep.
these two syllabuses, and that is very natural. It's not anything strange.
Yeah.
But the focus is important. Actually, what developers syllabus is focusing on is to teach developers to develop GeoAI algorithms. What we are focusing on is that appliers can use the algorithm. So we don't expect students in this course to develop an algorithm. They just use it. But in the other course, they need to develop algorithms. But of course, they can be used, and there could be synergies when we are developing course materials.
Yep. But anyway, so at the end of the course of both group, you may make one single team so that you may complement each other team. So to reflect the demand from the user and learn the aspect from the developer and so on. So can make a more synergy.
Indeed, yes.
Yeah.
Yeah,
And one very quick one is we may include some data visualization. Visualization is something that I don't find from
You're
you.
right.
Yeah.
That is right. Yes.
We have specific course of visualization already.
Yeah.
but-
Yeah.
And we didn't list it, so.
But for instance, all the part related to GeoAI and ethics is something that can be also proposed in the for the first course.
I think indeed it's possible there is an overlap. The target student, it's a bit different. So it might be that the topic is the same, but how you are going to teach the topic is different because you have a different pool of students.
Mhm.
So in the first syllabus, we are really aiming to have very good coder. That is probably not what it's aiming in also in the second one. So you teach similar topic, but with different way of understanding the topic and use it, the techniques. So there is indeed an overlap.
So the main target of the student, it is graduate student, of course.
We
Not
can
exact-
say like that. There are students who have probably a master in GIS and remote sensing. They are
Mhm.
working in a company and know they want to learn AI.
So they have a
in
very
GIS
strong
and-
background of GIS.
They have a background of GIS remote sensing. And maybe one of the reasons that we exclude visualization is that they have already studied
Mhm.
that.
Lovely,
Yeah, that was
yeah.
part of the discussion. Yeah.
Okay, all right.
That generally, if you already have a curriculum and if you have significant GIS experience, you have experience with visualization.
All right, okay.
Yes, please.
I'm wondering if the ethics course for that you presented could be taken by like leaders in that organization who may not have like any coding, but they just need to understand the general ethics around GeoAI, so they can better understand
I
what their
think so.
appliers are doing.
Yeah, the question is that, sorry, I'm repeating for audiences online. The question is that the ethic module can be studied by leaders of the organizations who need to learn about AI governance. And of course, yes, that's a very good suggestion and observation, I can say. They indeed need to learn it because they are the ones who should support AI activities and also make sure that all ethical aspects will be followed and respected while AI is used in the projects.
Yeah, it would be awesome if that could be like standalone as well as part of this program. It's great. Thank you.
It is actually also part of the third working group discussion that we had with you. So we work on with decision makers, and I think this is an overlap which we also saw.
Yeah.
So we included the same course there as well, but maybe from a more cost benefit analysis and also like impact measurement long term. So for decision makers, the course content could be similar, but needs maybe some more additional content as well.
Mhm.
Other questions? No, no. Thank you, thank you. So at this point, we can go to the presentation of the third working group. And please, Pravati, come here. So the working group is the syllabus for decision makers, as we mentioned them. Decision makers, it means.
I should have looked there, yeah. Hi, everyone. Good afternoon. I'm Parvati. I'm originally from India, currently based out of Netherlands. I work at an institute called Analytics for a Better World. It is part of University of Amsterdam, and we do a lot of professional education courses for nonprofits and development sector organizations. So that's my background. And today I'll be presenting GeoAI for decision makers, but I'm presenting on behalf of the team, of course. Both of them, I think, are not here, but have contributed significantly to the whole curriculum. So Sohail and Lokendra, I think they are listening in if it's available online. But yeah, this is on behalf of them as well. So I want to, before going into the curriculum, talk about the process that we followed while developing this. So kind of our journey. So we started by understanding who exactly the user is, like who are we developing this course for? And we also wanted it to understand what their demands and requirements are in knowing GeoAI, or do they even have the requirement that they want to learn it? And if they do, what kind of questions are they struggling with in their day-to-day decision-making process? We then identified a few examples or samples of users that we thought might be interesting to reach out to. We did some focus group discussions. We interviewed a few. We also had like surveys sent out to very short ones to decision makers at development sector organizations like World Bank, UN, but also to universities with professors trying to understand what kind of professional education courses they are currently developing. So we send around these user interviews and also some focus group discussions. And based on this, we curated a syllabus. And then, of course, there were a few iterations, and the arrow is not always like this. There were like in between steps also a lot of confusion trying to understand exactly how we put this together. So we did in total 12 focus group discussions. We had 47 survey responses and 10 interviews like in detail we conducted, and we decided to narrow it down to 3 modules with 32 subtopics, let's say. By 3 modules, you will also hear it later when I speak a bit about characterizing the learning itself. So when we started, this was our idea. So we thought that they will be domain experts. So let's say they have a PhD in environmental science with a minor in data science, and also they might be overseeing global environmental initiatives and have challenges in understanding how exactly GeoAI can make an impact in their organization. And we like kind of played around with the thoughts like, okay, do they need to know prediction models, optimization? Do they need to understand what these different concepts are, or do they just need to know, yeah, it exists and what kind of use cases are out there? Then when we did the interviews, we came up with a few questions. So how familiar are you currently with GeoAI? What are the interesting topics for you? What is the preferred format? Because yeah, we can either make it completely online, but we could say that it have to be blended. And most of the feedback we received was for blended learning, because they also saw a lot of relevance for peer-to-peer learning. They wanted to know what others in the same field are working on, what kind of use cases they are developing, but also what challenges they faced so that they don't have to repeat the same mistakes others are already seen in their work. So we saw that the preferred format was leaning a bit towards blended learning. We also saw that for them, time commitment is a big issue because for them, GeoAI is not their focus. They have other responsibilities and they want to learn. Of course, they have an interest, but time commitment is a problem. And this particular example was from agriculture and food startup. So this person was the director of operations, and he said, yeah, I can spend less than 1 hour per week. That's maximum I can do in a week. And I do not prefer courses which are spread over months. I prefer some focus time where I can completely dedicate to the course and come out a different person. And then we had this public sector colleague who is a senior urban planning specialist who also had similar feedback on blended learning, but there the questions were more on how do I remove bias? Because in my company, whenever we get pitches from, let's say, appliers or even developers on GeoAI, also nowadays we hear a lot about generative AI as well. We always think about biases, and especially when they are working in public sector and government organizations, it is a huge challenge for them. So their questions were a bit around regulation and biases, also on ethics, more rather than understanding what use cases are out there and what others are doing. So we had a few user personas developed, and we took away a few key takeaways. So blended learning plus some in-person workshops were the preferred format. Networking and peer learning opportunities were really highlighted. And we saw that they prefer more practical with minimal theoretical background. Of course, they see the relevance of theoretical background, but they are not necessarily GeoAI or even developers who understand geospatial data that to the extent that we can teach them a lot of theoretical courses around this. And like I said already, time commitment is less, and it's better that it's not spread over time. So we develop this kind of a characteristic. So they are domain experts with some understanding of application areas, not really remote sensing or GIS, or they are leading experts in geospatial, but they want to understand how they can use it in multidisciplinary activity. So there are different personas that were emerging, and we thought about, do we need to educate them, like by teaching more theoretical foundation courses? Do we need to raise awareness by showing what others have done and creating a platform for peer-to-peer? And we also thought, should it be a training which is more on a specific skill or focused discussions on a particular topic? So we, for each of the character learner that we identified from our data, we tagged them that some need more education, some need training, some are more interested in just awareness on what is out there. So using this data or information in the background, we started developing the curriculum. And we came up with this objective that we want to provide decision makers with a solid understanding of fundamental concepts, including GIS, remote sensing, spatial data analytics, and geospatial machine learning, but only like some understanding of what are the concepts behind all of this and what are the challenges that are emerging. But more specifically, we wanted to explore real-world applications in different sectors. And this is also, the previous speaker have said, it could also be based on the cohort itself. So in some cohorts, maybe you need more disaster response kind of use cases, because if there are more participants, if some groups are more from agriculture sector, maybe you need more use case around that. So it also have to be, I think, driven by the cohort itself, what kind of use case or industry experts you actually invite to these courses. It cannot be really, a cookie cutter way. I think it have to be tailored. And these were kind of the course objectives that we came up with. So fundamentals of GeoAI, we want to help them conceptualize and lead GeoAI projects, but also at an organizational level, usually the question is, if I want to start a GeoAI project, who should be in the team? So do I need developers? Do I need appliers? Do I need some other like project management skills? So how do you constitute a team for a particular type of application? These kind of questions is not very well covered in traditional coursework. So it would be good to also teach how they can conceptualize and lead GeoAI projects within the organization. Most importantly, the overlap with the previous working group as well, recognize ethical and societal implications. So I think there, like I already discussed before, we have this overlap, and I think it's a really good one because, of course, appliers also form a big part of the team that usually pitch to decision makers, and same does developers, because basically as a decision maker, if within the company or organization, if you do not have the resources to implement projects, you can forever just conceptualize. So all of them have to ultimately work together. And if there are fundamental courses across these three streams and these three users, I think it is really good. Of course, how much deep you go into each differs based on the cohort, like I said. And last is about staying informed on emerging trends. This whole field is changing really fast. There are like startups coming up. There are new announcements every week, and thought leadership around this is very important for decision makers. They want to understand what is happening, but also what are the challenges and risks for their organization if they don't invest, and if they invest in certain type of technologies for their use case. So I think staying ahead and informed of the emerging trends is also equally important. So through a combination of lectures, case studies, and hands-on exercises, we want to help them identify opportunities to integrate GeoAI into decision-making workflows, because most organizations already have project management and decision-making workflows, and how we can integrate GeoAI as one part of it is something we want to look at as part of the curriculum, and also evaluate different technologies and tools for specific use cases. And it is equally important to understand how do you optimize resource allocation and do like impact assessment and cost benefit analysis for projects. And lastly, which is very important and which we already heard, is how best to collaborate in technical teams to deploy these kind of applications. And I think it's not very easily taught by course, of course, but it could also be workshops or even like hackathon settings where people come together and try to solve a problem, where it could be a mix of developers, appliers, and decision makers coming together, rather than an individual working on something on their own and trying to learn from it. So I think that's also a very important part of the whole process. This is the list of modules. It's let me quickly check.
No, you have
I have time.
yes.
Okay, good. So I think for the first module, which is fundamentals of GeoAI, we want to cover, of course, some introduction on scope. What is the value add, especially across various sectors, key technologies, and here it's important not to go too deep, but make it relevant and make it understandable for them. And this is also where one of the previous questions on visualization actually helps, is how do you communicate complex topics to a user who do not really need to know it to the extent that the trainer probably knows. So as a trainer, you might be a huge geospatial expert. And for us, it is very easy to communicate to someone who is at our level. But how do you actually visualize and communicate those results to someone who needs to know it at a bit higher level is actually very tricky. So that's also something I think in the key technologies we need to think about. And of course, applications of GeoAI, which should be cohort-based, like we discussed. In the second module, which is on implementation strategies, this is where we would like to cover like decision-making, like frameworks and models, building and managing GeoAI teams, collaboration and communication. And here also there are a lot of digital and technical tools available these days. So if we could cover some of them, and also giving examples of successful companies who are geospatial developers and have made these kind of products at scale, and showing how they do this and manage workflows as case studies would be, I think, very, very helpful. And of course, last is data analysis and interpretation for decision makers. So how do we develop tools and softwares for non-technical decision makers as well? And the last module is on non-functional aspects and future trends. So ethics, privacy, and policy in GeoAI. And here, beyond ethical considerations, I think data privacy and security is also a huge discussion point, which we need to consider. So with the rising number of generative AI applications, which are able to automatically get our location. And also we saw like farm boundary delineation, and there is like a lot of use cases where we could identify a lot of personally identifiable information or PII from generative AI, and GeoAI applications are using a lot of it. It becomes important to learn about data privacy and security in the context of policies which are relevant for the country or the region that you are working and operating on, and how best to consider that in your decision-making process would also be added in this particular module. And emerging trends and future directions. So of course, there is this thing of staying updated, but it's also equally important to know how do you create, how you can create decisions and tools within the company which are standardized and they are actually top of the line, rather than doing something which is still in the nascent stage, and understanding the fine line between experimentation and scalability. So these kind of things are very, very important for decision makers. So I think most companies and organizations, they are okay with experiments, but the problem is when they define and conceptualize it, they think that, yeah, this is something which we can immediately scale, but there are numerous steps between an experiment and a large scale application, both implications in terms of cost, data, in terms of analytical capabilities, etc. So those kind of things also, I think, should be discussed in this particular module on non-functional aspects and future trends. So these are our modules and some of the topics, and we really hope that this kind of courses can actually help unlock the value of GeoAI for decision makers. Thanks.
Okay, thank you. So yeah, we have time for questions.
Yeah, again.
Speak louder.
This was awesome. So bravo. I can already think of a lot of our partner orgs that I would suggest this to. And I just wanted to say, like, the objectives that you laid out, I think could apply to so many areas, emerging technology beyond just GeoAI. I thought they were really clear. And I often see things like, yeah, strategic thinking, like how do you build a team to apply this? I don't see that as often in these kinds of training modules, as opposed to just learn the technology at a high level. So I just want to give kudos and say I'm excited about this.
But this was one of the topics that came up very often in our user interviews. So I think it's also the process, that process helped us a lot, because they were like, yeah, we want to do it, but how do we set up a team for this? Do we do it in-house, or do we hire consultants and just let them do it and give us a product? So it is a huge need for the industry.
Yeah.
Other questions, comments? Yeah.
Thank you.
No, I have a curiosity. So in your survey, did you also ask questions to members of the public sector, like administration and so on? How they are prepared with respect to that? What is the level now?
Yeah, so we did have a few responses from especially public asset management teams. So for example, within governments, they are mapping roads, or they are mapping public investments. So they had a lot of questions on climate resilience, like we want to make our investments more climate proof. And we do have very less amount of geospatial data, but we want to do it. So they wanted to know what open data is available that we could use, like Sentinel, for example, or can we use it at the resolution? So these are very fundamental questions, right? Like, yeah, for this use case, can I use Sentinel, or do we need to improve the resolution of the imagery? So the decision makers do have, especially in the public sector, these kind of questions. Also, we had some government responses from government agencies. So they had questions more on collecting the data itself. So if I want to develop GeoAI applications, what quantity and quality of data is actually required? So that's also something that is not known, I think, yet for decision makers.
Okay, so focusing more on data than on algorithm or
For them, I think that's
or
what.
models.
Yeah,
Okay.
yeah.
So thank you.
Thank you.
So at this point, I propose, even if we are a bit earlier, we can go for the last presentation. And in such a way that we can have a longer break then. To go on both sides. Yeah. Do you want to search for your file? Yes. Which is, where is it? Yeah, it's a search.
Okay.
Okay, then the presentation mode. Okay, that's fine. Okay.
So before starting, I will say, like Ali, please move a little bit. It's the last presentation, so you can.
Yes.
Yeah. Yes, you have. Okay.
Don't worry, we have time because the other presenter were very quick.
So thank you very much. And I apologize, my two co-presenters. So Song, really, he's the master of this group, and he's really specialized in GeoAI. He just co-edited a handbook on GeoAI, and unfortunately, but fortunately, I would say, he just had a baby last week, so we can acknowledge that.
Yeah.
And also, unfortunately, Samantha, she was supposed to be there, but you know, there were some climatology issues in US, and so her flight was canceled, and she had to come back home. So maybe she's online.
She didn't
Maybe.
come here swimming.
No, she did not. So I will present for everybody, and I hope to make it well for you to understand. So as you presented at the beginning, Maria, this body of knowledge is really think and conceived to be in parallel with the different syllabi on GeoAI with the 3 different levels. Also, so we should support this initiative of training and to have really the corresponding vocabulary. So we just started, but we need, as I will show you, to the people of the different courses to complete and to put their needed vocabulary. Also, maybe we can make some debates about some words because it's a big issue. Also, it should be adapted to different levels and pathway. And this, we can think about that as well. And also, we should, in the next step, maybe, but already to see how to implement it, because of course, the vocabulary has got to be up to date every time, every year, every month. And so we should put an online system enabling an easy contribution and access for learners and teachers. And so we identify 3 main issues. So what is the knowledge area that we can just begin to implement with collecting when the courses will be implemented, all the detailed vocabulary. Then how to coordinate with existing project of body of knowledge that exist now for a long time on geographic information science, and also how to take advantage of some practical tools that were already developed in this area and in this existing book that we identify, but maybe elsewhere. And so to complete, so for trainers, trainees, the private sector, and so on. So I will start with the knowledge area. So I will learn you nothing. We are at the intersection between geoscience and GIS and artificial intelligence, of course. So we just, and Gao is really the master for that, to define the 4 main categories of words: geospatial machine learning and deep learning, generative GeoAI models, geospatial knowledge graphs, and geospatial data and machine learning stewardship. So stewardship, I use this term for ethics and data management, because in ISC, for example, ISC Codata, Simon Hudson, he really pushed to use this term, which is better than management or whatever. So it's really an issue also on data. So we have these 4 different groups of terms, but we started to list, but it's really far to be complete, and it can be completed anytime. So the issue, as I said, is to coordinate with the courses, but also with the existing GIS body of knowledge. So we identify 2 main projects that are old and ongoing. The first project is from US. It is named UC GIS, so a consortium. It exists for a long time, for 30 years. They made the first edition of body of knowledge in 2006. So it's really, there is a longer, the long history. And so they collect more than 300 topics. And there is a hierarchical structure I will show you. The second project is a little bit similar in a way. Also, they are connected each other, actually. So, but it is different also. It was supported by the European Union with 2 European projects. They are now in the second project. And so it is a European consortium. So the first project, you see, put together was supporting by Erasmus Plus Action. And so 25 partners, 50 associates, 22 countries. So it's really also a big project. So they set up many tools. I will show you some tools. And now they started last year the new version of the project, now named Space for Geo Alliance. So we met 2 of this consortium to really see how we can develop the GeoAI body of knowledge with them. And so they are now also developing new extension, and it could be one of these extension. So just to introduce you a little bit these 2 projects, the first one, so the UC GIS, has got a nested structure. So you have main terms, and inside you have more precise, and inside even more precise, and so on. So it is I don't know if you know RDF structure, so resource data framework, with parents and children. So they have 10 main topics here, and there's no GeoAI. So if we want to put GeoAI, it would be spread in many in many topics. If we compare to the other project, the European project now, you see it is a little bit similar, but actually the terms at the top, so it is also a nested structure with parents and children, but the terms, the 14 terms are not the same. In particular, they have here geocomputation. And if we want to put GeoAI, it would be around geocomputation, more concentrated. So we don't know what to choose still. If we come back to the first project, UCGIS, it's not totally nested because there are some links between the different words that are not nested. And so it is what they call the living textbook. So it's more network oriented. And so this is very useful to create pathway. So also you have the learning outcomes. So these are, for example, the different slides or files for each word. So you have, they indicate in which topic is it. There is a code indicating the hierarchical level. So they have genetic algorithm, for example, already of this kind of word. They also introduce schemes to explain better. They have, of course, references. And if we come back also to the second project, the European one, we have also exactly the same living textbook. So it means how far they are linked each other. They use more or less the same kind of system, but they develop it independently with two different hierarchy and vision of the world. So it is really very interesting to see these two projects. In this second European project, there is an interesting tool indicating some learning paths. So for example, if I want to learn how to make spatial data modeling and computer representation, I got to follow these paths. So it was defined by some people. And so we could be inspired on that, and also with the courses and the syllabus to develop different paths like that. So they already also developed some general paths, developers, appliers, deciders, so to coordinate, of course, with our working groups. And they offer many training materials that you can access with filters. So there's plenty, it's really very huge. So they also offer a tool very useful, I think, for job offers. For example, a private company wants to offer a job. It indicates the main competencies here, the main skills, and some people, they put also their CV, putting their skills, and they see how many people match with their the skills they want. So it's really very good. And so these are for the two main body of knowledge. The European body of knowledge, so you see GIS, is a part of a larger network, which is called iGuide. And here we have a main representative, Eric Schock, who is also one of the partners with the University of Minnesota.
Not European, this is the American.
American, excuse me.
Yes.
Ah,
European, yes.
Thank you. So it is the American one, so yes. And so you see there are 11 universities, but even there are some consortium. And before you spoke about Nadine, who is in Open Geospatial Consortium. So they are in this network as well. So many things are linked, and I tried for myself also to understand who are making what to not replicate, because we have really to integrate. And actually, it is a worry of many many institutions now. I think about UNGGIM for the geospatial information ecosystem. If we build Riyadh, if they build Riyadh, I think that they have also to integrate in this large community, to be linked with them, to use their resources, because there's no no utility to replicate, but to use and to link together. And the role of new things should be to really integrate in the new thing. So like modules, and this image of iGuide, I think is nice because there are different modules, and maybe we can add the or reinforce this geospatial AI and data science here. And so also, as we have already contact with them here and elsewhere, we should really make the things with them and to link everything together. So they have in this iGuide platform many resources, open and reproducible GIS resources. They have also a curriculum for geospatial data science. So they start with some different, let's say, blocks of knowledge. Then they connect these different knowledge, and then they create some framework, and what they call the problem convergence at the end. So they start with a modular, a little bit as it is conceived for some of the curricula. And so they think about, and this, I think this is in progress now. Maybe Eric will say more on that. So it's just a very short presentation, but there are many things to learn from this already existing project and to integrate in this project. So I think that we have these four main topics. So we have maybe to consolidate it or today, if you agree on that. But of course, they have to be now completed when they are agreed, and to see and to discuss how to coordinate with this existing body of knowledge. We with a song, we think that it is not a moment to choose one of the two projects, but to integrate in both. And so maybe to have an American team and a European team and others, as I would say, to make this a very practical thing, and to integrate into the GeoAI ecosystem information. I think it should be very important as far as I participate to the, I will present you later in my second presentation as the chair of UNGGIM Geospatial Societies. Really this Riyadh center should really also strengthen this ecosystem GeoAI information. So we were a small working group led by Song. Thank you very much.
Thank you. I don't know if you want to add something about the American project.
Which Which one? iGuide,
or-
yeah. So iGuide, top level is a funded project by U.S. National Science Foundation. So it's a $15 million project spanning about 70 different people. Our institutions, groups, collaborators, and everything else. We're organized into 6 teams, which were the kind of pretty picture over there. I'm the co-lead of education and workforce development. I'm also leading the convergence curriculum for geospatial data science. So the nice little pretty diagram is my baby in the project right now. One of the goals of that particular curriculum framework was to develop it in such a way that you could fit it into already packed curriculum. So one of the issues that you have around at least the US, where I'm focused, is that you don't have enough time to add many extra classes and things like that. And sometimes it's not developmentally appropriate, or that's not the learning outcome. So for each of the boxes, we actually start with a 3-sentence description. So that if you just want awareness, you can just say, this is GeoAI in 3 sentences. You can introduce it in 30 seconds and you move on. If you want to go a little bit more depth, we have 3 slides with the definition, a kind of high-level driver, and then this discussion point. So again, in about 3 minutes, 3 to 5 minutes, you can introduce something like GeoAI, you can introduce something like geovisualization to a particular audience. And then after that, we have a 3-hour module where you get into more depth with a traditional lecture, some readings, reflection, and a hands-on activity. The hands-on activity, of course, is key if you want to start building up skills, knowledge base, and things like that. So that's kind of what we're focused on right now. It's been in a very developed and listening focused process. So it's been a little bit slow to develop, but that's because we're really trying to get as many voices in as possible before we start really rolling out development. So yeah, that's.
Yeah. So it's really essential to be able to match the different topics of the teachings with every term that is defined in the body of knowledge.
Yeah.
But it could be also interesting to see which are with respect to, because okay, we don't want to deal with geospatial in general, because first of all, already exist. There are 2 bodies of knowledge. So the American and the European one, but we want to focus on GeoAI. But it could be interesting to see also if we agree on the definition. And then I think that what we are missing are people from Asia. So I'm looking at you. No. Yes. So yeah. I don't know if we have also some body of knowledge from Asia Pacific we are not considering here that can be useful for us to know if there is a third flavor or what. So it can be that, in my opinion, we have to search also if there is something there. There is nothing, for instance, with respect to Africa, nothing with respect to Latin America, because this is America, but North America, this project. And so try to see if there is something, if there are colleagues who already started working on that, or try to elicit them also for having a diverse point of view with respect to things that is richness, in my opinion. Yeah.
Well, we did not find others, but maybe.
Yes.
Yes, I have a question for, maybe this is for all panelists. So you've talked about this curriculum, and you always say that this is multidisciplinary. So usually, in which department are these courses set up, or where would you recommend them to reside?
Ali, Andrea, do you want to answer to this question? Do you want me to answer?
I think for developer will be probably a master that can be, this kind of course can be erogated or in a master in computer science, That's, I think it's the first, probably good place where to put it. Or there are master in geomatics or in geospatial data with students that have kind of same background. Depends on the university, I think. But in general, I think probably a master in computer science will work quite
Could
well.
be also engineering,
Yeah,
computer science. or
yeah, I
engineering.
mean, yeah, computing. Yeah.
Like, well, if I can, I pull on that because I mean, being an economist and trying to bridge between statisticians, geospatials, and more social careers, I think that this would be very helpful for people that study these kind of schools that are usually trained in I would say like regular statistic or normal programs of statistics that usually now require or would be interested to know more about geospatial or GeoAI. So I'm afraid that these cannot reach other disciplines where this can be very useful. So for example, for designing policy or for evaluating social programs and things like that, this could be some new tools that would be very helpful for social scientists. So I think, I don't know, I'm thinking in terms of how to introduce these to these kind of disciplines.
Yeah, so I totally agree with her. And as you mentioned, so three working group develop a very nice program for which cover almost everything. And we may make it a little bit shorter program, so-called, we call it micro degree. So with, for example, I don't know the European system, but anyway, within 10 hours or 20 hours, we can teach a little summary, but the overview. So this is a micro degree and a little bit mini degree, medium degree. So the micro degree can fit into the social science, or something, yeah, something like that. So, but I think after we develop this one, this could be one of the next step that we have to tackle.
Yeah, the main point is that every different courses, what they have in mind is to develop is as modular in such a way that then you can use the different topics, mixing as you please. But coming to your question, Paloma, I believe that teaching a course like this one in is not a soft, the one for developers is really for people who are coding. I see more teaching or a course like for appliers or for decision makers in other universities like for economists, for sociologists, and so on. For the developers, they are supposed to be very good in coding. So
Now, I want to add, because here we are targeting a different, we are a different goal. Interdisciplinary, it's a very difficult subject to teach, at the university level. So these are like more traditional way of teaching these courses that we developed. In case we want to teach like this topic with interdisciplinary approach, so you involving people from with a background in economics, in ethics, in philosophy, that maybe they cannot really study how to code this. We should think about different approaches where we put maybe developers, applier, economics in the same course, but then it would be a challenge for university how to handle, because I think universities are still not really ready to do this, but we should probably put them together to not to learn the techniques, but to think how to use them and implement and challenge them on how to integrate the technology. So it's very challenging, but it was a bit different with respect to what we started to do.
I think one thing to take into account is time availability as well, right? So if you're at a decision maker level, you might only have 1 hour a week, or you can devote 3 hours and that's it. You're never gonna get to algorithmic development in GeoAI in 3 hours.
Always had a mini course.
Yeah. So I mean, I think it was natural why there were 3 kind of working groups, because you do have a little bit of difference in depth and just kind of in breadth. So you have a lot of depth, I would say, at the developer level. It's a smaller cohort of people that are probably going to be in your catchment area. The applier could be pretty broad, right? You can imagine them fitting many categories, and then the decision maker narrows back down, right? But very different than the developer, mostly with communication ability. I say that with a background in computer science, so I can pick on the computer scientists and lack of communication abilities.
So one of the key challenges is to work together with some, for example, some professor in economics or some professor in sociology, something like that. So this is quite a challenging one, but anyway, this is a way to work with it. Of course, we can provide a very mini course, and after that, if you want to a little bit get into a little detailed thing, then we may collaborate with really interdisciplinary way. So this is one of the challenges that we have to.
You're gonna share the slides and the presentations, or where can we look at the results of all these projects? Is there any repository that we can go into?
Yeah, with respect to this, slides and syllabi will be available on the website, the YouTube website, where there is also all the video of the workshop of today. So everything will be available. If you want to have something extra, you can ask to me and Andrea if we have. And for sure, I believe that 2 main points are of interest, considering that this is not the final program for the final syllabi for the courses. This is the activity that was done in the last year of people thinking about that and blah, blah, blah. But for sure, what you mentioned, so considering also other disciplines, is important. And what I mentioned also to have a more geographical representation of the people contributing, because really this is an activity mainly done by Europe and North America, I have to say. And so it's really relevant if you are from other parts of the world to try to elicit professors contributing to this project.
Not from our working group. Our working group is a bit more spread. We have represent members also in Africa, in Asia.
Yeah, it's true.
And there are people from India.
Yeah.
In the different groups. Yes.
But yeah. It's good to have
Yes.
We need more commitment.
But I have to say that then the chairs and the people who contributed more were from Europe and North America. And that is a pity. Yeah. Okay. So other questions?
I have people
Yes.
from Latin America that I can suggest to participate. Can share.
Okay. Good. So at this point, I propose to have the break.
Maria, for the invitation. It's a pleasure to be here today. I want to start saying that you should be very proud of the work that you just presented. I think that the work that you're doing is very relevant. This morning in the center stage, we heard about being, Doreen said, we are the future generation, or we are the AI generation. And while listening to you, I think you are training the AI generation, because we didn't receive proper training in AI, and you are really preparing the AI generation. And I think this is very relevant. Every forum that I go, they talk about AI. If I'm in a healthcare forum, they're talking about AI. If I'm with statistics, the topic of the year is AI. And if I'm with climate, it's AI. So everywhere it's AI. But you're really talking about the important thing, that is, how are we going to train people to really understand what they're doing? So really, I enjoyed the presentations before. I think you're doing a very relevant job, and thank you for coordinating and organizing this workshop. I think it's very important not just to talk about what AI can do, but how are we forming these next generations. So today I have I want to talk to you about what we do at, let me see how to advance, UNGGIM, which is a United Nations Global Geospatial Information Management Committee of Experts. Then I'm going to talk a little bit about what we do at the National Statistical and Geospatial Office of Mexico, specifically centering what we do at the Data Science Lab and what kind of profiles we are looking for. And maybe this will be of help for you because you are thinking, or at least I would think that the people that you are training are the people that we would like to hire in a geospatial agency to generate geospatial information. So derived by GeoAI. And lastly, I'll talk about collaboration because I really believe that that's the center of everything we do. And if you find an organization with someone that doesn't want to collaborate, then there's no way you can advance in what you're trying to do. So UNGGIM, for those of you who don't know, the United Nations Initiative on Global Geospatial Information Management, it really aims at playing a leading role in setting the agenda for development of global geospatial information and to promote its use to address key global challenges. It provides a forum to liaise and coordinate among member states and international organizations. And the committee is mandated, among other tasks, to provide a platform for development of effective strategies on how to build and strengthen national capacity on geospatial information, as well as disseminating best practices and experiences of national, regional, and international bodies on geospatial information related legal instruments. So UNGGIM mainly makes joint decisions and established guidelines on the production and use of geospatial information with national and global regulatory frameworks. It promotes common principles, policies, methods, mechanisms, and standards for the interoperability of geospatial data. And it provides a platform for developing effective strategies on how to build and strengthen national geospatial information capacity. So I really believe that this is a forum where you should focus in terms of necessary frameworks or necessary policies to develop GeoAI. And the potential use of AI for official data has really increased the response and demand from stakeholders and related decision makers. And with the development of applications of AI in various sectors and purposes, including official statistics, geospatial information, the role in its governance, as you know, it's becoming increasingly important. And AI governance is also a new stage in the development of data governance, especially in exploring the theory and practice to improve the management and utilization of organizational data. So governance frameworks address data quality, security, privacy, ethical standards, define the roles and responsibilities of stakeholders, and also mitigate potential risks associated with the use of data information. So strengthening these national geospatial information management arrangements in countries is really the main topic for UNGGIM and can be achieved through the implementation of an integrated approach to geospatial information management. This is the Committee of Experts' main line of work, which is based on the implementation of the integrated geospatial information framework. And the idea of this framework is that it needs to serve as a means for strengthening national geospatial information management arrangements within and across member states at the institutional level, and supporting the implementation of the Sustainable Development Goals. I really believe that this pathway has set up as a catalyst for geospatial information and, of course, GeoAI that is derived. And it can serve as an intergovernmental blueprint that comprises of 3 components. An overreaching strategy, the implementation guidelines, and now the countries are deriving their action plans in order to how they are going to achieve this. And I think this is something that might be of interest as well for the programs that you just presented in terms of how, I mean, you're teaching the technical background, but also you need to know how to implement it, what's the governance around it, but of course the technology, the people, but also the legal frameworks, the finance around it. So it really integrates all these 9 pathways in a very strategic way. So the proliferation also of GeoAI must be accompanied not only by the components of governance and regulation, but also by principles of conduct that allow its ethical use, which implies understanding the rights, obligations, responsibilities regarding its use, as well as protecting the privacy and maintain confidentiality. And in the absence of an official authority regulating the ethical use of data, it is very important that geospatial information producers and users really commit to establishing ethical considerations with national and regional initiatives. And during the last decade, the use of AI for generation of statistical and geospatial information has acquired an important role. As I was saying in the beginning, it's the hot and sexy topic, but it's also generating problems and concerns regarding the privacy of information and the individual surveillance. So this proliferation makes it increasingly difficult to guarantee and ensure privacy, security, confidentiality, as well as the correct, legitimate, and adequate use of data generated by AI. So both producers and users concerns about negative effects and risks related to its misuse. So in the information generated by AI, we believe that it must be always accompanied, and as you said, by codes of ethics and privacy, security, and have all these principles that we always have established for desirable data management. And in this way, I share with you that in 2019, Ethical Geo and benchmark initiatives joined to initiate an international dialogue focused on exploring what it means to use location data responsibly. And the results obtained with these dialogues concluded that it was necessary to develop common international guidelines and principles that guide users to how to exercise the use of geospatial data responsibly, as well as the understanding of the risks that its use represents. In this way, an international collaboration group of producers and users was created in 2020. And this group, it's called the Locus Charter, and it was launched in 2021. So up until now, this is kind of the framework, the principles that guide international conversations around geospatial data that might apply to GeoAI. And now I want to share a bit of what we do at INEGI, as I said, the National Institute of Statistics and Geography of Mexico. So INEGI's, and I'm gonna focus on our data science laboratory that has the research and area that aims to develop new products based on data science environment. And the laboratory is composed by several profiles, which articulate the life cycle of the projects. So we have domain experts that have criteria to validate and evaluate the results that are obtained and facilitate access to the data. We have data engineers, and they perform data cleaning. Data architects, they do the data interoperability, and data scientists that generate training sets which are necessary to train computational learning models, resulting in artificial intelligence algorithm that can be used to analyze large amount of information. And last, we have the solution developer, the development of data products with an end user view that transforms data tables to images, maps, webs, and applications. So this new paradigm adopted in INEGI is really generating the demand for specialized profiles in data science. And one of the main achievements of the data science laboratory has been the articulation of a data lake, which allows the integration of statistical and geographic information. So we have a more fluid transit from information generated at the statistical department to the geospatial department. And so this data lake is really a storage repository designed to contain large amount of data in various formats, and it facilitates a consolidation on information through its analysis and processing. So the data lake integrates information available on the web, traditional INEGI sources, geospatial information, including Earth observations, and third-party information as well. So this information represents, of course, large volumes of data, and it is necessary to have this architecture that allows the management of big data. So we have our own data center where we have all the information. And the data lake is mounted on a technological architecture compatible with INEGI's technology and capable of meeting the needs of the laboratory. So an information architecture that allows extracting information and generating visualization data necessary for the integration of different data sources. Once the data lake infrastructure is in place, the profiles described above are distributed in each of the stages of information processing in the data lake. So we are allowing the implementation of workflows that enable the fulfillment of data science life cycles: ingestion, storage, visualization, integration, analysis, and visualization. Yeah. Isn't it, next slide, sorry. Yeah. Yes, thank you. And with a view to automating the stages that have to do with data extraction, loading, and transformation, so that the work of data scientists can be concerned on the generation of data and products. Now, I want to talk about a specific project that exemplifies the work that we do. This is a project that we're working with Idea Maps. This is we work with a colleague from the University of Twente that I was just discussing with a colleague from there. And the primary objective of Idea Atlas is an ESA funded project, and is to develop, implement, validate, and showcase advanced AI methods to automatically map and characterize the spatial extent of slums from Earth observations data. So this will support, of course, the national and local governments, as well as civil society, to monitor progress on the SDG 11.1.1 on the proportion of urban population living in slums, informal settlements, or inadequate housing. And the project builds on previous work generated with Idea Maps. So what we really do is provide clear guidance for collecting data on various aspects of deprivation, while allowing the flexibility to decide at the city level which indicators are most relevant to explain individual domains. So building on the guidelines that Idea Maps framework provides, we generate a collection of open data sets that we found relevant for the indicators group, and the collection of the matrix. So really it's about identifying all these data sources, putting them together, and trying to get some base. So what we did is we put all of these data is statistical data, so it's transformed to a grid coming from different data sources. We're integrated into grid cells using proposed technological novel methodology. And this new methodology implies the use of the data lake technology for the integration of these data sets. And the pipeline allows for further integration of more data sets. But since we have several types of information at distinct levels of spatial resolution, we define a strategy with different cases to integrate data into the grid. And we identify 3 cases in which data sources can fall, which is when the data is represented as a point in space, when the spatial areas are smaller than the proposed grid, or when the data sources have closer granularity than the grid. And of course, at the end, as I said, of this cycle, we have integrated everything into a single table that can be used for visualization, and that then you can probably provide to the decision maker and showcase where the informal settlements are. But of course, it is behind a lot of analysis correlations or machine learning models to do it. So this is just an example of integration of different data sources in different profiles that you need for collaborating and experts to do these kind of projects. So collaboration, I really believe that it's around collaboration that we can further implement the artificial intelligence tools with digital transformation, assisting governments in decision making. So we cannot work alone. Artificial intelligence experts or geospatial analysts cannot just work with AI automated information processing and stop really there. So large organizations have to begin to adopt these methods, interact, and of course share content visible to anyone. So we need the professionals, but we need also them to know about the policy, about the frameworks and everything that I talked at the beginning. So we are able to implement. I had a professor when I studied at Harvard that said that there's like that divinity, like it's a triangle, and then you need to know what is technically correct, but you also need to know what's administratively feasible and politically viable. So it's not only the technical part that we need to focus on, that's very important. If we don't have the money, we don't have the political support, we're not going to be able to implement. So we need that impossible trinity to really implement forward the project and be successful. And I think that's around the collaboration. So I'll stop there and happy to take any questions. Thank you.
Hey, thank you. Thank you. Questions, comments? You are. Yeah.
Yeah, do you have a website?
Of INEGI?
Yeah.
Or even GGM or
Just to like find the tool.
oh yeah, INEGI.org.mx.
Yeah. So while the other people are thinking about questions, I was interested in the example of slums, because, for instance, this can be a good example that we can put also in the curriculum. And the point is that everything is open, I believe, so it's available. And but can be this model reused also in other parts of the world, or how much work it did? Because if we are able of teaching how to use it, and the model is available for everyone, as satellite data are available for everyone, it's possible to teach also people how to compute in their country, not only Mexico.
Yeah, so this Idea Maps project, as I said, is a funded project and it's being developed in many countries. So it's not only Mexico. I think there's countries in Africa and other parts, Brazil, I think is participating as well. I can send you the list of countries, but this is something that we could do. Yeah, and yeah, we're working with the University of Twente on that, so we could check.
Yeah, thanks for the presentation. I have a question on the informal settlements. I guess this definition could probably differ by country. It's not just about spatial
congestion, but also population density. Are these kind of things integrated in the definition?
Yeah, exactly. So I think I showed where there's like a diagram of the different variables and those change country by country. I would say that in our case, we're very lucky to have the statistical department and the geospatial department under the same roof. That doesn't happen. I think it's only Mexico and IBG in Brazil that has the statistical office and the geospatial in the same organization. And that's very easy for us because then we can do all this gridded information because the statistical department can give us the data in like individual data and we can put it in the grid instead of using administrative boundaries. For example, talking to my colleagues in Australia, they say they have a very tough discussions between the Geoscience Australia and the ABS statistics because they cannot send data because of confidentiality issues at the individual level. So this is something that for our project specifically has been very helpful and that allows us to get those maps at a very granular level and not have, like, for example, population at municipality level, no? Or other levels that sometimes you cannot disaggregate because of confidentiality.
Celine first.
Yes, thank you. So to continue on this collaboration between statistics and geospatial research, UNGGIM is under the responsibility of UN Statistics Division, but it seems that there are no so many integration and communication. I don't know. Many people come from statistics actually, but when I go to different meetings of UNGGIM, I see very few really integration between both.
Yeah. So both are bodies that report to ECOSOC, the Economic Council for Social and Economic Affairs, so that the Statistical Commission and the Committee of Experts on Geospatial Information, they're both subsidiary bodies of ECOSOC. So they have the same level actually in the organization, but the secretariat, it's called UNSD, so Statistical Division, no? And they have the Geospatial Department. Well, I attend both every year, the Statistical and the Geospatial Commission, and I have to say that usually what I think is that the geospatial community, we're always talking among ourselves. We never go to the statistical forums, or we never go to the climate change forums, or I see like the geospatial people are only talking to geospatial people. And I think it's very important that we really reach out to other communities to showcase the use of geospatial. So this year, for example, we hosted in Mexico the IAOS. So these are the International Organizations of Statistics. And we focused a lot on geospatial information and artificial intelligence as well. So I think this is kind of that's why maybe I'm thinking about multidisciplinary approaches and how really to get out of your own department and talk to others, because I think there's a lot of value there, and geospatial has a lot to offer in other. And I think statistics, time to time, they have come to recognize the value of geospatial, and even though they use geospatial, of course, because everything happens somewhere. So when they collect a statistical unit, they have coordinates. So they are collecting spatial data for me, but it depends how you think about it. But yes, I think every day more we need that integration, and I agree with you.
I think like a lot of humanitarian organizations that like are using this kind of data to actually like give to like first responders, they're really hesitant to use like machine learning based kind of like maps of like settlements or like refugee camps or whatever. Because I think like they feel like it may not be accurate, and if it's not accurate, you don't really have any accountability for why it isn't accurate. So I know like the humanitarian OpenStreetMap team, like they still only do like manual like drawings from satellite images of like where settlements are, and like they've like looked into like using like methods like you were doing, and they've just like flat out rejected it. So I don't know, have you had any like collaborations with like the humanitarian OpenStreetMap team, or like how do you kind of get around that bias for like entrenched kind of organizations? Like they're just really hesitant to do these kind of like machine learning based predictions.
Well, that happens in my organization as well. Yeah. We have a lot of people that are reluctant to use them because they feel like
And especially statisticians, I would say, what's the confidence interval and what's the error? And this is something that I think we need to work on these models in terms of how you say, well, this is the map, but what's the percentage of error of that map? I mean, if you can say this is the map, but it has 95% confidence, then you would use it. But if I tell you this map has 50% confidence, then you say, well, that's drawing a coin, so I wouldn't use it, no? So we need, I think that's something that the community that works on models needs to work on in terms of how to provide these tools, but to also showcase the confidentiality of these data, because you never know. It's like I'm working now with the land use and land cover people, and they say, well, you have your model, but for some crops, it's 50% accuracy, and for some crops, it's 90% accuracy. So if you're looking for the crop that is 90% accuracy, then you would say, okay, I use that map. But if it's 50%, then you wouldn't use it. So, and also it depends, I mean, how much time it takes you to map by hand, whereas maybe 50% chance in an emergency, it's good enough. So I would say it depends on the problem that you are trying to tackle. And if there's a hurricane and you need to go in and do some humanitarian aid, use the 50%. I mean, it's better than nothing, no? So I think you need to.
Yeah, but this is important also as something that we need to teach. Not only to click here, click there for obtaining a map, but also what is the accuracy of what we have. Because sometimes people are thinking that, yeah, I'm using machine learning. Now I have the map, right?
I had a lot of trouble to convince statisticians that that information can be official statistics, because I always say, we're official statistics, so we're giving the stamp, and it's taken years for a statistical agency to gain confidence. So I cannot put out whatever. I need that confidence or precision indicator, accuracy. So it's very relevant. Yeah.
Last question.
Just to kind of follow up on that question, I've seen applications where they'll take in the AI produced building footprints, and then like HADO-SEM through like MapSwipe and what tools like that will then try to understand the accuracy of those AI produced footprints. So I've seen like really cool combinations of AI generated maps and human interpretation of those to try to get better accuracy. So I think it exists and it's growing.
Yeah.
Yeah.
Thank you for sharing.
Okay. Thank you.
Thank you.
Thank you. And now we have Andrea. Andrea, it's your turn.
My turn.
Shall I introduce Andrea, or is not needed? Okay, so now Andrea is speaking as ITU and also UN Geospatial Network and also AI for Good.
Wow.
Nothing else.
I have different hats.
And you have 5 minutes.
It was 10. It was 10. Because
Okay, 10 minutes.
Yeah, I don't
Yeah,
know.
it's not 5 minutes, I remember, yes.
Yes.
Please ground.
Good afternoon, all. No, I can't.
Yes.
Not coming. Yeah, it's coming. Yes, so I will share my presentation parts. I will talk about the UN Geospatial Network, and then I would speak a little bit about the GeoAI for Good competitions, which we are organizing in partnership with Zindi, and which are a complement, I would say, of the activities which we are doing on the webinar series. So, what is the UN Geospatial Network? So it was set up in 2017 as one of the thematic network of the UNGGIM. So the objectives of this network are to strengthen the coordination, collaboration, and sharing mechanism on geospatial information within the United Nations system. One example that I can make is that
many agencies needs to procure satellite imageries, but each agency is buying independently from the vendor. So if we pool resources, we can reuse imageries. We can have license for the GeoAI system, so we optimize resources and we
Save money.
and we save money. Increase communication and awareness to senior management of the relevance of geospatial information and its management. As an example, in ITU, we are responsible, we are the UN specialized agency for ICTs, and all ICTs is dependent, I would say, on geospatial information. So I'm very much interested in highlighting the role of the special information, let's say, for smart cities, climate change, for deployment planning of 5G. So it's a different approach to what we are doing actually in ITU, and promote availability, accessibility of coordinated geospatial data to support member states and United Nations mandates, promote the use and relevance of geospatial information from the states and the UN system, and then, of course, support the mandates, aims, and objectives of UNGGIM. So only to mention how we are organized, we have a chair from UNEP, we have vice chairs from UNESCO and the WHO, and then we have a steering group. And as ITU, we have been a member of the steering group since the inception of this network. And then we report to UNGGIM each year. So we have grown now to up to 40 agencies. What's happening?
Yeah, that's
Up to 40 agencies. And just to explain what we're doing, so we developed this blueprint, which is our strategic document. So we did the first an investigation of the geospatial data and services which are used in each of our agencies. And then we see, okay, what do we do to work together and improve what we are doing for better serving our member states. So we deployed these strategies, which is 3 priorities: governance, technology, and people. And we have these 7 transformation pathways. And I have to say that if we see what we are doing in GeoAI, I will say that innovation and technology, we are very much involved. Partnership as well, capacity development, that is one of the very important goal that we want to achieve, and outreach. So with these activities, we are perfectly in line with the mandate of the network. We are doing some publications to show how each agency is using geospatial information. And then what we do now is that we organize GeoTalk, in which each agencies can show what they are doing. And now what we are doing now is that we are building up this one UN geospatial situation room, which is a sort of delivery mechanism to bring coherence on data governance. So each agency has its own geospatial infrastructure, and then we want to share it with each other and build up this one geospatial situation room. And as you see, each organization is custodian of given geospatial data sets. as an example, in ITU, we deal with ICT infrastructure, and by federating this data, we can have a single point of access for member states. Just as an example, we discussed before the fundamental geospatial data themes, which were defined by UNGIM. So in the transport network, ITU is providing ICT infrastructure data, and FAO is providing land cover and land usage. So now I would move to the GeoAI for Good competitions. So we have been organizing competitions since a couple of years. And what we say is that everything happens somewhere. So we need to apply machine learning to geospatial analysis to solve real world geospatial problems to advance the SDGs. So all what we do is open software, or open solutions, open data. And I have here a QR code if you want to see the algorithm which were implemented in the past competitions. So what we do is that normally the first part of the year we discuss with different agencies, different partners, and then we identify some problems, and then we launch a competition. And finally, we use the Zim platform, which will be presented afterwards by Paul. And then we receive the solution. They have an automated leaderboard, so the submitters immediately see where they actually ranked. And when the competitions is close to the end, you see really that people are really submitting solutions, optimizing the algorithm. So is very dynamic at the end. And then at the end, we evaluate not only based on the accuracy, but also on a report, because we want to build up knowledge. So we want to see how they reason, why they choose a model or another, how they optimize it. Just to give a few numbers about last year competitions, we had 5 problems, and then you see as an example that for the first competition we had over 300 registered participants, but finally only 74 submitted the solutions. And then we will have here a special guest that is one of the winner of last year competition, so she will describe which was her experience with this competition. So we had 2 problems from GeoLab,
Yes.
Politecnico di Milano. Maria is always very much involved in this
Yes, I have the
effort.
t-shirt.
And you got the t-shirt, not more. Yeah.
This is the reason.
Yes. Then we had the competition from ESA.
Yes.
Sabrina is here. They revitalized their hyperview competition, and
I was seeing the numbers again.
Yes.
Yeah.
Yes. So you had also a good number of participants and solutions from 19 countries in Africa. So maybe it's not what your normal audience.
But that was one of the purpose, because if you remember, we revamped this competition, which already ran only for Europe and our usual audience. So it was interesting the fact to go beyond
Exactly.
to, yeah. That's why we should do it again.
Yes. We had a competition also not only on satellite imageries or sensor data, but also on social media data. Because I think it is very interesting to experiment with all different kind of geospatial data. So also for educating people to see what is geospatial. And then we had, yes, a competition from the cropland mapping from FAO and from UNODC, also built in the frame of the UN Open JS initiative. I was discussing with Lorenzo Vita, that is from UNODC, the Drug and Crime Organization of the UN, and they were saying that they were very happy with the outcome because they had several solutions that are assisting them to understand the potentials of these new technologies and tools. The competitions that we are evaluating this year that will be launched soon. I'm very happy that we have also something about the okay, we have a competition from FAO again on plastic mulched field mapping, competition from GeoLab on air pollution, a competition from a new entry, the United Nations Global Service Center, which want to detect water body as small as 400 square meters, so just a pixel in Sentinel-2, and monitoring of illegal mining and clandestine runaways in the Peruvian Amazon. So, and also ITU as a competition on ICT infrastructure images, how to extract ICT infrastructure from existing maps. And I will end up here by giving the floor to Stella, which will explain which was her experience in
Connect your laptop. No.
Hey, thank you very much. My name is Stella Ampofo, and I'm a PhD candidate at the Technical University of Munich. And yes, that is me, and this is me in life. So I'm also under the chair of data science and earth observation. So we are bringing together remote sensing and AI, and we are developing a lot of use cases in agriculture and population estimation, but also going beyond the application domain to things like uncertainty, reasoning, ethics. So it's quite a big and diverse group. And so today I'll just be sharing my experience on the crop mapping hackathon. But my PhD topic is actually crop yield prediction. So I use a lot of remote sensing, multimodal remote sensing data set and time series information to try to forecast. By forecast, I mean in-season prediction. So we want to know what would the yield be before the harvest is actually made. Okay, so back to the crop mapping. So I think the idea was to solicit solutions for mapping crops in 3 different regions. And the setting was quite unique because I have participated in a couple of hackathons. Usually you are given a certain kind of data sets, which is already split into some training and some testing. And then you have some ground labels to associate this. But this was unique because you only have access to the ground labels. So you have to innovate your own way of bringing different dimensions of data together to make the prediction. And there was also a catch. So these 3 regions were Afghanistan, Sudan, and Iran. For Sudan and Iran, there's a whole year of temporal information. For Afghanistan, you have a very limited window. So this was the catch. for us, some assumption was made. We considered that these 3 regions, I'm not an agriculture expert, but I was assuming it's possible that they have different agroclimatic conditions. So by this assumption, we decided to make independent models for each country. Now, our workflow, our data collection workflow was based on Earth Engine, Google Earth Engine, because the idea was also to develop solutions that are practical. So, I mean, what best than to use publicly available systems. Okay, so for the type of data set that we have collected, I mean, amongst the competitors, we see that different kinds of choices were made. For us, based on our past experiences, one thing we know is optical data is very informative for crop phenology studies and for crop mapping. So by this, we also restricted what types of data we considered. Okay, and we collected the data as time series because, I mean, using single data observations is not enough to tell apart maybe crop from a weed or some other kind of non-cultivated area. And we also we're going for simplicity, meaning less features, simple models. And I guess this kind of things are more appreciated in an operational case. So what we found out that using very classical machine learning, I mean, these days when there are challenges, people just jump on big models and whatnot, but we decided to start simple. So we went by conventional machine learning algorithms, our random forest, so support vectors. So we compared across these algorithms. And we see that, frankly, when we have a lot of temporal information, these models can achieve over 96%, which was quite very good. But in the case of Afghanistan, because we had a very limited temporal window, the accuracy was a bit lower. I remember Maria Andreas saying that what we term lower is actually not very low because it was already in the 80s. So for hackathon people, it's always, we are going for 100%. So that is why they think 80 is lower, but it was already good. And one thing we also observed is when we take this raw Sentinel-2 spectral bands, we enhance them with some indices, and we try to increase the feature space, the model performance degrades. So this was also an observation that we made. So in Afghanistan, we then tried to find some ways to improve the performance. So what we did was to use some deep learning models that more or less pay attention to the temporal order of information. So like your LSTMs or like temporal convolutions to decompose patterns in time series information. So by doing this, we were able to add up a bit, maybe up to 3% in the 80 something plus accuracy, which was also quite a nice insight. But the question is 3% really enough for you to go deeper? So finally, my takeaway is that it's always good to start simple. More data, more feature space does not necessarily mean a better performance. And yes, I think that generally these hackathons are a very good way to innovate solutions to real world cases. So finally, I would like to thank ITU for this opportunity to be here and to share my experience, but also to learn a lot about what AI is being used and thinking about the ethical concerns and things of the sort. So that's the end of my presentation.
Congratulations.
Very much.
And this gives me the opportunity also to say, if you want to propose challenges, feel free to do that. But remember, and then you want to say something.
No. You're saying
But
that it is my
remember that it's
special.
not only a matter of providing the data, you need also to mentor then the participants to the challenge, helping them in building the solution. So there is just, we are proposing, not we, ITU, so Thomas here, Zico there, and ITU are giving available the platforms. But then if you want to propose something, there are not people behind that working for you. You need also to do the work. But it is very rewarding, both for the students or young researchers and for the people who are proposing the challenge. Okay, thank you.
Thank
Thank you
you.
so much. And we have also Paul.
The presentations, right? Yes, presentations.
So Paul, 3 minutes. You paid for 3 minutes. Yeah, and now it's recorded forever.
I was also speaking.
I was joking.
There's one here. Full screen. This is. It's somewhere up here, but this is all.
Affichage peut-être. Affichage.
Control
L.
Affichage.
Control Yes. Okay, hi everyone. I'm gonna have to speak really fast, but fortunately, Andrea and Stella have already spoken quite a bit about what Zindi is about. And thank you very much for hosting us, to you and to Thomas as well. So Zindi has worked with ITU for the last 18 months on as a partner to host AI for Good challenges to make sure that they reach new audiences, broader audiences, and that applies across a number of challenges, not just Geo for AI. Very broadly speaking, Zindi is a professional network for data science. We started as just a competition platform, but users now use it to advance their skills, get practical learning, get access to opportunities, as well as winning prize money. We have around 70,000 users representing almost every country in the world. Something like 60% of our user base is African. We started in Africa. Most of our challenges are African, but really we have a global footprint now. We've given away, that number's out of date, probably closer to $700,000 in prizes, again, mostly to Africans. So we see ourselves really as building AI and machine learning capacity on the continent. And we've done this through more than 300 competitions over the last nearly 5 years. I'm going to go quickly past this, but essentially we try to bring organizations and individuals together in one place where they can move so you guys can see everything. We try to bring individuals and organizations together in one place, and we see ourselves as an ecosystem for practical machine learning and AI on the continent. And we are actually expanding beyond just machine learning now into data engineering challenges, data visualization, generative AI challenges, and so on, as well as hosting learning content in the next month or two. So organizations work with us to reach our community. We have an ambassador network across more than 30 countries, as well as deliver solutions or develop solutions. So we're delivering best in class models and creative approaches. And I think this is what ITU and GeoAI appreciate, is that you're seeing new and unusual approaches to challenges, because we're sourcing from this very broad crowd of ideas. We are working on a talent solution, but I'm going to zoom straight past that. In terms of our partnership with ITU, we've run, I think now 15 challenges, with a couple more on their way. I won't say too much, but we can expect some challenges to come. More than $50,000 in that says funding, that's prize money. So money given to individuals, which is amazing. We've engaged thousands of users across these challenges. We calculated something in the region of 65,000 hours of work on these challenges over the last 18 months. That's an estimate because we can't be sure, but that's about what we think. And more than 100 countries represented on our leaderboards. I don't really have time to show you the platform, but if you're interested, come and see me afterwards and I can show you what the platform looks like.
So in terms of GeoAI, we've run 5 competitions and there will be more. We've given out more than $8,000 in prizes, and we've had more than 1,000 contributors with more than 12,000 machine learning models submitted over the course of these 5 competitions. You've seen these already. This is just the various challenges that we've run. And I will wrap up there by saying this is a really valuable partnership to Zindi. ITU and GeoAI specifically have brought really diverse and interesting challenges to our community. And that is like the fuel for our community is to have really meaningful challenges on the platform. This is just one of our users saying that he's running out of compute because he can't keep up with all the AI for Good challenges. So it's been a really fantastic and fruitful partnership for us, and looking forward to continuing that partnership. Probably no time for questions. I don't know. Up to you.
One question, because we are very late.
Otherwise,
From yeah. So I was just wondering, like, what happens like after the competition ends? Like, do you have any inkling of like how useful these solutions are to the end users? Because like I've won a few Zindi competitions myself, and like we like followed up with the nonprofit, and they gave us data for like the subsequent year. It was like agricultural data, and our model just didn't work at all because it was like super overfit to the 1 year of data that Zindi had available, right? So
I mean, it's a super relevant question, and it's awesome to. I'd like to chat afterwards to hear your experience more. I think for us, it's such an important aspect of what we do, because traditionally machine learning challenges like this, people just optimize for accuracy. They ensemble a bunch of models, they overfit, and it doesn't actually work in reality. Zindi puts in a basic clause that we disqualify users' submissions if they're not valuable to the client. So we are very, very committed to delivering something of value to whoever the client is or whoever the host organization is. That being said, there's a lot more to making a machine learning model useful than building a model with really good accuracy. So we try to work as much as we can with those organizations. We try to support them as much as they can, but it's really up to them. And the results differ wildly. Some of our challenges, they sit in the equivalent of a dusty drawer and never get looked at. I mean, we've got a challenge now that they're implementing, they haven't even got the solutions, and they're building the infrastructure to implement those models in production. So it runs the full gamut, you know, but we do try, and we're trying to get better. So I'd love to hear your experience so we can maybe improve.
Thank you. Okay, and sorry for cutting the questions, but now we are late. And Kijun.
Right.
It's your turn for presenting UN OpenGIS. So you got 5 minutes.
Okay, I will make it within 3 minutes. This one.
Time is finished.
Right, so beginning.
Just wait.
Okay, all right. Okay, so first of all, I'd like to thank Maria and Andrea for inviting me to such a very nice event. I'm Kijun Lee, working at Busan National University, and also serving as one of the co-chair of UN OpenGIS initiative, together with Maria and Joseph from UN headquarters, UN GIS section. So this one. All right. So I'd like to begin with some very historical thing. Do you remember what happened in 9 March 2016? It is the day when AlphaGo defeated the #1 player of Go game. So this is the first one. And the second one is we had the very first kickoff meeting of UN OpenGIS in Brindisi at the UNGSC. I think
Yes, yes.
you are here.
Yes,
somewhere.
I'm there, yeah.
Anyway, so the reason that we made this UN OpenGIS initiative is that we found some common points between OSGeo. OSGeo is an open source software foundation for geospatial thing, and the United Nations. That means one of the goals of the United Nations is to unite our strengths without barrier. Without barrier means open source. So this is a background. One of the background, and the real background is the money problem, the budget. So because using open source software, we can save the money anyway. So the goal, so what we are doing, we are trying to provide open source software solution for geospatial domain to United Nations, because UN are carrying out several operations using a GIS, like a most of the peacekeeping operation, they are using a map and GIS solution. So the scope of our UN OpenGIS initiative is first try to provide open source software for system and solution. And the second one is capacity, which is probably more important than the first one. So this is the main goal and scope of our initiative, and who are working together. So there are three main players. The first one is, of course, from inside of the United Nations, like UN GIS section of headquarters, GSC, and several peacekeeping operations, for example, from African continent and agencies and fund and programs. This is the main one. And the second one is, of course, many contributors from OSGeo Foundation. And of course, we have a lot of participants or volunteers from academia and industry. These are three main stakeholders of UN OpenGIS initiative. And how are you working? This is the structure, governance structure of UN OpenGIS initiative. So here we have 5 working group, and one of them is GeoAI and analytics, because geoanalytics is mainly based on GeoAI. So this is why we merged it into one single one. And the working group 2, capacity building, is one of our very successful story. And based on that, you may consider this working group as a kind of incubator. And based on that, we launched several real projects to apply our solution to the field. So there are many projects incubated from this working group. And there are some achievements from our UN OpenGIS initiative. The first one is capacity building. So we run several training programs. So the main trainees are from the United Nations, first of all. And then the second one that I'd like to mention is we set up a so-called hybrid architecture, because most of the United Nations, they are using a commercial product, the so-called ESRI product, most of them. But these are, sorry, is there anybody from ESRI? No. Okay, so these are quite expensive. They have, so the staff from the United Nations, they have to use it, but they want to migrate from the commercial product to open source product. So we try to build up a kind of a hybrid structure so that the fundamental server could be either the ESRI one or open source one, and the client or the application could be commercial one and the open source one. So this is a very practical approach for UN OpenGIS initiatives. And what we have done, we have done a lot of very interesting projects, such as UN Vector Tile Toolkit, the cloud-free satellite imagery, mobile OpenGIS, and OMIS story map, and Open Drone Map. These are some examples. And also GeoAI. So thanks to Maria and Andrea. So you have done a lot of the function, of course. So a very wonderful thing. So this is the final slide. It is within. If you want, you may go to the site of UN OpenGIS initiative. You will get a more detailed information. So if you are, it is open to everybody. So it is totally based on volunteer. So if you are interested in, you may contact with Maria or me or anyway. So this is a website. And I'd like to conclude my talk with two things. So I understand now why you invited me. So the reason that you invited me is to find out something for a GeoAI education.
Yeah.
Right. Yeah. So, well, I think of that. Then I'd like to propose two things. The first one, so this is one of open question, and we may discuss it during the panel discussion. One thing is, when you run the GeoAI education program for master students, then you can set up a kind of capstone project or pilot project at the end of the education. Then the topics can be afforded by the United Nations. So this is one way to run the education program by yourself, and we can collaborate with the GeoAI education program. This is number one. I think it is not very difficult. It can be done quite easily. We have some group for collecting the requirement from the field mission of the United Nations. So I think it could be done. And the second one is, it is quite challenging, but for example, the potential trainee or student of the education working group 1, education working group 2 could be the UN expert. So the officer from the United Nations. But the problem is, for example, our university and Politecnico di Milano has the same problem. It should be
I left there.
it should be a little bit, for example, in our university, we have a regulation that more than 50% of the education or lecture must be given in person. But that should be online, if I understand correctly. So if we can find some university where we can afford the online lecture more than 50% or eventually 100%, we may open that program in one of our university. That could be possible. So, for example, I'm not quite sure, but in Politecnico di Milano, you try to persuade your university that
we have already Geospatial AI at the Politecnico, yeah.
So that could be 100% online, or
it is in person, but also online and also recorded. This is the situation at Politecnico.
Yeah. So
the idea is that the lecture is given in presence, but students can connect from remote.
Exactly.
And the recordings are available for
something
a
like
posteriori study.
Yeah, something like that. So if we can run this program totally based on that way, I think that could be very, I think this is something that we may think of. So that is my conclusion.
Thank you. No, it was more than 3 minutes, but I knew.
All right.
Okay, thank you. And now Celine, again, the Geospatial Society.
In 30 seconds.
Very quick. Meanwhile, Tiziana is preparing herself.
Yeah.
Oh, it's me. No, certainly later. But can you start to prepare?
Yeah, that you need to be.
Okay, so my presentation will be, I think, complementary to others. And so we are now 11 geospatial societies. And linked to what was just before, we just welcome the Open Source Geospatial Foundation and also the International Science Council CODATA. And so I think that they will really reinforce the cohesion from our group with the others. So also to complement what was already presented, to present UNGGIM. So what is it composed of? We are 4 networks here. So you saw the geospatial network of the UN agencies presented by Andrea. You have the academic network chaired by Maria, private sector chaired by Zafar, who is not there. And so I chair the geospatial societies. Besides, you have different regional committees with the different region of the world, and the bureau with all the co-chairs and the rapporteur. This is Paloma in Mexico. And actually we meet once a year, at least with many other events, but once a year we all meet together in the beginning of August in New York, in the headquarters of United Nations. And actually the members and the main actors are not at all us here. They are the countries. The countries, like in United Nations, make the General Assembly, and we are only observers. But we are here to support and to help the different groups of these actors, these national actors. And actually, who are, I discovered last year, so I can share with you, who are these national actors? They are in general, like Paloma, for example, the head of the geospatial or topology institute of the countries. And so they represent the countries and they decide different things. And we are here to help them in different working groups that meet during the year, but also they report every year for this meeting in New York. And so the working groups here, so you have 11, I will not, of course, detail the working groups, but actually how Geospatial Society, we participate. So you had a presentation of one situation room by Andrea, and our society participate to mostly all the working groups, but not in one situation room, actually, and not in the integration of statistical and geospatial information, because, not because, but we see that these two groups are led by the UN network. And so they are making their thing, and actually we are not, as academic or societies, we are not really involved because it's more about United Nations agencies, I would say, purpose. Maybe we will discuss after that. And also to the regional committees, so there are some meetings in different regions, at least once a year, but sometimes several times, and we participate also. And last but not least, for some years now, the UNGGIM created 3 different centers. So Bonn, the UN Global Geodetic Center of Excellence. And so we have some societies very involved in that. Dachin, I don't know how to pronounce it, Dachin, which is in building now. And we have also some members in the committee for the building. And now we are discussing Riyadh to build, as I already mentioned before, the Geospatial Ecosystem Center that, in my point of view, should integrate most of all the education training that we are developing here, and that we show that there are many initiatives and that create the ecosystem actually together with the countries and with the actors and governance and so on that create all these actions. So for the geospatial societies, yes, the only thing, so we, when I arrived 1 year ago, there was, well, all these, well, people, they have their own networks, but there was not a vision on what is the contribution of geospatial societies. So we decided to participate more. And so I was involved in many things, but only us, we decided, beside what was done last year and what is doing now for so all the syllabus and so on, to make a survey inside our societies to make like a database of what are the courses, webinar training on geodata and AI. So it is in progress. We launched it in March. I relaunched it twice. And in exclusivity, this is the first answers we received. So the map, it is, of course, far to be complete, far to be complete. But it's less than nothing. It's more than nothing, excuse me. Also, we see that African centers, they answered, I would say maybe it's overrepresented than, of course, in US or Europe. Also, China is not well represented, of course. India neither. Austria, nothing. So I will, of course, relaunch it, but just for knowing, for now, what I counted in the answers is that more than the half of these trainings are in presence, and a fourth is in mixed. So there are mostly half remotely and in presence. The language are mostly in English, but they are also mixed and national language. And what they teach, so Python is 78% of, well, 78% of the centers, they teach Python, JavaScript less, and R, SQL, API, and cloud deployment. Over the 68 responses, only 8 training teach all that. So about 12%. And last but not least, over on the answers, always 78% they teach ethics and safety of data and models, and 69 territorial policies and governance. Well, that means also that it is positive, but that means that, yes, 30% do not teach territorial policies and 20% not ethic and safety. And that's it. So also you have some information about how societies in our website, which is managed by the Federation of Surveyors. Thank you.
Thank you, Celine. Thank you. And Tiziana, are you ready? Tiziana.
So, Maria, I guess I'm getting 2 minutes, right?
If you're lucky.
We'll try to be as
Let
quick
us
as
do
possible.
3 minutes. Yes,
We'll try to be as
okay.
fast as possible.
And then Wembo, you can prepare yourself. Do some training now.
Okay, so thank you very much, Maria and Andrea. It's really a pleasure to be here. I have a presentation that I will try to shorten because I know people are getting tired. I want to go home. And these curtains started to close. I think AI telling us, your time is up. So anyway, my first slide I will not go through. The main reason I put a slide on governance is because practitioners, those who use AI for good, for sustainable development, I do think we need to keep this governance issue at the back of our minds. My worry being that if the governance goes too much over-regulated, it may actually reduce the freedom of operation that we have. And I can say from the ESCAP, so I'm from ESCAP, one of the 5 regional commissions of the UN. We cover Asia Pacific. So I can tell you that on the governance, we don't have a mandate. We don't have a mandate to even discuss governance of AI. But so far, nobody has stopped us from using AI tools. So we've gone ahead, but I cannot help but wonder how long can we continue? But so the governance, we just, as practitioners, we need to keep it at the back of our minds. Data is central. AI has proven very, very good at integrating very complex data sets, analyzing, et cetera, Up to now, it takes whatever it can get its hands on. It doesn't filter for quality. And that, I think, is another sort of issue that we need to keep in mind when we become enthusiastic with the results of AI. We need to be critical and think about what data was used. And second is the problem of data sharing. And the data sharing problem is sectoral among government ministries, among universities, I think, as well. And secondly, among countries. And so very complex issues at stake there. We are taking a bottom-up approach because there is no global framework to which we can anchor ourselves, although there are initiatives. So we're working with pilot countries, 2 countries, 3 countries, and trying to promote some common understanding on data sharing. Then in terms of our use cases, so this is one example, once again, using the pilot approach. So we have gone down to the municipal level, the local level. We have started using geospatial, AI and geospatial for local SDG monitoring. And we started off with 2 countries, Indonesia and Thailand, and then we moved on to expand it to Sri Lanka, Uzbekistan, and one more, I don't recognize the flag. But the key thing here is that we work with countries that express interest. It has to be demand driven. If a country, doesn't like the UN to come in and start at the local level to generate geospatial and AI analysis, it just won't work. And we've also expanded the goals. And basically it's, I think the innovation here is that we use AI according to principles, ethical principles. In the AI modeling, we ensure it's participatory. Through the modeling, we generate the sex and age disaggregated data. We also use the sex and age disaggregated data. And then this is all integrated using the large, the LLMs. Another use case is flood and wildfire risk hotspot mapping. We have worked in close collaboration with UNU, the IWHE, they're based in Canada. Yeah, this is just one more example. I won't go into the details, but I'm very happy, to follow up with you by email or in person as you prefer. So, the importance here of what we're doing or the value added is improving the accuracy and improving the timeliness of flood risk assessments. And once we can improve the accuracy and the timeliness, then the early warnings can be issued in a much more impactful way, because early warnings need to be impact-based. They need to tell people what is going to happen to you and your house and your family. If you just issue an early warning category 4 typhoon, it doesn't mean much. It has to be meaningful to the individual lives. And this kind of work helps in a very, very big way. And it also helps in terms of timeliness. If early warnings are issued too early, people just go back home when even before the danger is over. If it's issued too late, of course, too late. If it's issued erroneously, then the next early warning won't be credible. So the more accurate, the more timely, the more effective the early warning system can be. It's also very useful in terms of assessing the damage after disasters, identifying the needs of the affected communities, and really prioritizing the resources for disaster recovery. Because we know that a lot of money goes into disaster recovery and it gets moved here, there, everywhere, according to power plays among people. If you have the evidence base, you can reduce a lot of that. But the key for ESCAP is really about disaster prevention, disaster preparedness, less about the disaster recovery. But it's part of one cycle, so you can actually use the same methodologies, the same information for the entire disaster cycle and across many different players in the disaster cycle. More information available at this link. So if you're interested, please do go ahead and have a look. And then let me see if I can just go back. I knew I was going to mess it up. Yeah. I knew it. Thank you. I need to just scroll down a little bit. The next slide I want to show you is just an example. Can you go down? An example of a training. And then this is where I'd like to express our interest in partnership, because we are very heavily oriented to capacity development. Thank you. We're very heavily oriented to capacity development. We've developed an online course together with a UNU on geospatial data analysis with ChatGPT and Google Earth Engine. We're very open, very happy to discuss further how we can consolidate or bring together with IGAD, for example, and many other initiatives, how we could possibly have a joint capacity development workshops, trainings, online, in person. And I did note, Maria, earlier you were saying you were missing the Asia Pacific content together with our good friends from Korea and others. We would be happy to work together and strengthen the Asia Pacific content. Okay, and then finally, just a few words on our risk and resilience portal. This is a portal that's very much focused on disaster resilience, disaster preparedness. And basically what it has done is it impact-based forecasting, which is the forecasting of what the weather will do to you in the future, it has automated. It has automated this forecast, and it has enabled, I think, the integration of a much more complex and diverse data set. And it has also enabled, I think, much more precise and faster analysis and more accurate. So I will skip my last two slides because I have surpassed my 2 minutes. But happy to continue the discussion.
It's good. Then you forgot to say that you are organizing a webinar on 26th of June about the platform.
Platform, exactly.
Yes, there is
exactly. Thank
this,
you.
there will be online on the AI for Good, so you can check and find and register and participate.
Absolutely. Thank you. Thank you very much, Maria, for reminding me. And what we can do, if you're interested, we can send you all the invitation, the link.
Then, yeah, we can do it. Yeah.
I can do it.
Yeah,
I
sure,
can do
sure.
it to the group.
Yeah.
I have the group email, right?
Uh,
Yeah, you've
yes,
been
yes,
communicating
yes,
with everyone.
yes.
Yeah,
and
so
and
we
put
can
it in.
send the link.
Okay.
Absolutely.
Thank
Okay.
you. Thank you again. And now, Wenbo, are you?
I'm ready.
And I have to apologize with you and Celine as well, because before B and P in Italy is impossible to have N. Is a mistake. And so every time I put M instead of N, sorry. And so then I discovered
It's
that.
not the first time.
For me neither. It was written by an Italian, that is normal, because for us, I remember when we were at elementary school, if you wrote NB or NP was.
Yes. You know, in French, it is the same.
It's a big mistake.
And I
It
know.
was a big mistake, I remember, the blue pen. Yeah. Yeah.
All right. Hello, everyone. It's late in the evening, but well, we have some blue skies at least. My name is Wenbo Chu, a work program officer, worked in the Geo Secretariat here based in Geneva. I feel very privileged to be invited to this workshop, my first time to this group, and just learned that so many work has been done, and I'm very sure that we can leverage some of the resources here for our community, and also potentially contribute to this group and the large community as well. So Geo has a ambition or vision that empowers anyone to use and contribute to Earth's intelligence, make better decisions for people, nature, and the planet. Then what is Geo? We are talking about Geo all the time. It's not the GeoAI per se, and we are a group on Earth observation. We are intergovernmental. We have 116 member government this year. So with Maldives joined us recently, and 170 private sector and civil society organizations. And we work with thousands of leading scientists and practitioners and decision makers. From its very beginning, Geo promotes open, equitable access to Earth observation data and information, so that to help decision makers understand, act on global challenges. And as I said, so we are not far from here in Geneva. We are hosted by the World Meteorological Organization, WMO. Okay, so here's a little bit of history about Geo. As I said, we are established in 2005 with a mission to make data, especially satellite image, available for everyone. Back in that time, I think we may all know, satellite images were very expensive and not affordable by many people, and especially developing countries. And with the support of our member governments, we facilitated the process to make the valuable satellite image archives open. So this was led by the United States of America to open up the entire Landsat archives, and committed to open the future missions as well, and followed by the European Commission, the Sentinel series, and as well as many other countries as well. So now it seems almost a norm for median resolution satellite launched by governments. The data should be open. But now the data is open, but it's not necessarily usable by decision makers, right? So it takes many steps to make the data, to convert the data into the information usable, digestible by decision makers. So for the second decade, so we mainly focus our efforts to create service for all. So we have a portfolio of 48 GeoWork program activities across various domains, from crop monitoring to urban development mapping to flood detection, wildfire detection, and so on. And we have generated a lot of services, and I will give some examples, those are relevant to AI. We just developed a strategy for post-2025, which was endorsed by our member governments last year, that we are committed to produce Earth intelligence for. So what is the difference from Earth intelligence and Earth observation-based services? So it's all about integration. So our challenges are so integrated. So from climate change, biodiversity loss, pollution, they are all connected. So decision and actions in the government, in one aspect may affect the aspect, and it's not always in the same direction. So how a government should balance its so understand the trade-offs and make the most sensible decisions and investment. So this is where Geo will step in. So we want to create integrated services. And within our strategy to create Earth intelligence for all, we are committed to leverage all innovative new technologies, including AI, machine learning, digital twins, cloud computing. So it's in the design of our vision. So, but how we are going to do this? And in fact, AI and machine learning is not new to our community. So we did a survey earlier this year to understand how AI is used within Geo. So we made a survey to our 48 work program activities. So it's not a big number, but behind those activities, there are hundreds of organizations and thousands of scientists. So actually, around 50% of activities are using advanced technologies on AI or moderate level, and another 50% identify themselves as a limited use of AI. So in the next hopefully 1 or 2 minutes, I'll explain several examples how AI or machine learning are used in our community. So we have initiative global water sustainability called GeoGlows. It uses machine learning for flood forecasting. So it might be similar to what Tizana has talked about, but this was developed in the United States in the Bayern University, leveraging the European Center for Medium Range Weather Forecast. There are historical data, decades of data, and also the near-term observations. So they use AI to learn the pattern how the river runoff and the river discharge, you know, to extract the similarities so that the forecast can be made for areas, you know, only satellite images are available, but without in situ measurements. And with that, so the initiative has operated in several countries, including in Malawi last year. So the government of Malawi used that information to issue the alert so that they can, the people can, you know, do evacuation in advance, and so comparing to other previous, you know, events, lives were saved, and the cost for post-event operation is also, you know, reduced for good amount. And so we have another initiative called GeoGLAM, Global Agriculture Monitoring. It provides monthly report for the FAO food market information bulletin, and it's an operational service. So it maps crop types, so that is global, and so it basically maps where and when and what type of crops are growing in a certain region, and similarly to the, you know, flood forecasting, it's about using the historical data, then areas where in situ observation is not possible, AI weigh in and fill the gap of observation, and it has helped governments like Southern Sudan and Ethiopia for their the food risk alerts. And the third example, I promise this is unique. So it's not about satellite image, it's about sound. Yeah, machine listening. So it's a collaboration project with Microsoft Planetary Computing. So in the tropical area, the frogs and toads are very critical and typical indicators for climate change. And so the team was able to set the automated devices to record the sounds, but then how to process the sounds become challenging. So if, you know, in a traditional way, it's done in a manual way, it will take decades to do that. But with the machine learning method, it's done within several days. Right, so that's the example we have been doing, and looking ahead. So we are building some key new initiatives. One is we work with CBD, Biodiversity Convention, Global Ecosystem Atlas, which will fill a key gap, ecosystem extent, and heat resilience services, you know, of heat risk and the vulnerability of the population, and early warning for all, I think we all know. Yeah, and we are building a AI subgroup to map the landscape and to connect people and exchange information and do better. Thank you.
I want to go to the last one, then if there are questions for the last speakers, we can ask after your presentation, after the last presentation, in such a way that we can also, in the end, listen to young people, Because we were thinking all the afternoon about preparing something for students and so on. So now we have here a real student, true student.
Yes.
Yes, you are, okay. And so we can listen to them and see what they have to say. Okay.
Yeah.
So the
Can
floor
I
is
stand
yours.
or do I need to sit?
No, you need to sit because if not,
Okay.
because there is the webcam. You see?
Yeah, I can.
can.
Yeah, thank you so much everyone for staying awake. And hello, my name is Yugandhar Yadav, native from New Delhi, and I'm a PhD student at Politecnico di Torino in Italy. And today I'm representing ISPRS Student Consortium. And in the next upcoming slides, I will take you through what is ISPRS, what is ISPRS Student Consortium, what we do, what are our activities, and how we can what we can do for GeoAI promoting. And yeah, and I guess that's all the time I have.
Yes.
Starting with the ISPRS, it's a non-governmental organization which is dedicated to the development and promoting the geoinformation science, remote sensing, and photogrammetry to the international cooperation people and the universities. And it's a bigger umbrella which has the different technical commissions related to the photogrammetry, remote sensing, sensor data, and to the education. And also, I cannot forget yours, spatial information.
Yes.
And coming to the student consortium, it's the official representation of the youth. Youth means people under the age of 35 to the ISPRS. And the aim is to connect the students from the universities, the young researchers, and the academician, and not just limited to the academy, also from the industry, young people, to the photogrammetry and remote sensing, because research and young people have sharp minds, so they can give the research ideas, and we can advance the geoinformation science, remote sensing, and photogrammetry. And this is the team for ISPRS Student Consortium. So we have the representation from across the globe. So Lakshmi Thapa is the president from Nepal, and she's a PhD in UK. Nicholas from Swiss, and he's a postdoc in Australia. Sunny is from India and postdoc in Zurich. And me, I'm from India and in Italy, and Miguel in Japan, and Chuck in Chakuama in Nigeria. So we have perspective from around the world to the consortium and different ideas in a single umbrella. And apart from the team, we also release the call for the volunteers. So where the students from the around the world can help us in different activities for the newsletter, for the designing of the graphics, for the social media. So they can also learn, and we also get a supporting hand in our activities. And starting with the activities, we have our newsletter spectrum from last 10 years, and it's a quarterly newsletter. The different topics of remote sensing from underground. Last edition was on underwater remote sensing, and the next one will be on the very hot topic of digital twins, focus on the urban planning, and maybe the next one could be GeoAI.
Yeah, sure.
And so
Not a maybe.
no, yeah. So I'll contact the people around this session for their contribution. And if you have any ideas, you can always contact us, and we can always bring up it up in the newsletter. And these are snapshots from the events that we organized. The summer schools, every year we organize summer school in collaboration with the multiple organization. And this one is from China, Beijing, and this one also in Florence, last year's SIPA Spring School. And apart from the in-person event, we also organize GeoMixture, which is an online webinar where we share the knowledge from experts to the young researchers about the different topics and emerging fields from remote sensing, photogrammetry, and the related applications. So if you have any ideas or if you want to organize any GeoMixture or any online event, you can always connect to us, and we can always support the event. And this is the something we are trying to bring it up, the student consortium student chapters. And the idea is to connect the regional universities to the ISPRS, main umbrella, and student consortium. So if they want to organize some event at the regional level, at university level, so we can provide them with small funds and connect them to the experts and with the logistics and organization stuff. So this will be very soon, maybe in a month or so. If your university or organization is interested in establishing a student chapter, we can be always reached out. And coming to the GeoAI, how we can contribute, sharing the resources, because we have more than 800 members registered annual. So we can share the resources, the syllabus, and the content to our members to get the feedback of what they think of and how the things can be taught to them, because all the members are under 35, so it's a big sample size. Also, networking opportunities within the members, and if you want to organize a workshop and webinars for the spread of GeoAI for multiple applications, that can be also done through the geomixtures or any other event if can be approached. And feedback from the community through the surveys and through the events, like what the people think of GeoAI and how they want to use it, and for what applications, for what kind of research work. So this can be also, ISPRSSE can also connect for this purpose also. And collaboration with the universities, because as soon as we establish the student, because we already have so many interests for the student chapters, so across the globe we can collaborate. We can have established the collaboration of GeoAI with the many universities. So it can be, and at the end, it's a win-win for all, for the developers, for the young researchers, for the appliers, and for the decision makers. So we learn from each other, and that's it. And I'll quickly take you through the surveys that we recently shared with our members. For now, the sample size is really small. We just received 50 responses, but we can get the initial glimpse of what young people think of GeoAI, how things can be taught. So you can see the members with ISPSSC, they are from different backgrounds, like GIS, photogrammetry, remote sensing. Some are from civil engineers like me, and from geomatics. So it's a diverse sample size. So most of the people, they just heard of artificial intelligence. Okay, ChatGPT, AI, ML, DL, and everything, but it's a black box. No one knows what's going inside. More, and especially from special science information, most of people are appliers. They just know how to apply for their specific applications, their specific use case. But people are also interested in learn what's going inside the black box. So most of the people are already using artificial intelligence, machine learning. Maybe people interpret as a ChatGPT, as a AI. So everyone is using it. So it's clear from the responses as well. And of course, I don't know what 4% people thought, but everyone is interested in using AI for sure. And these are the different responses we received, where the people want to use AI and machine learning for neural networks, for the point cloud processing, for 3D modeling, for robotics, and or these kind of applications. And as the sample size grows, we receive more responses, and we can include it in the syllabus. And how you want to learn. So majority people say online, because it can be learned at self-paced. And second one is in maybe hybrid, because everything cannot be taught from the online courses. Some aspects of GeoAI requires the hand-on experiences and in-person discussions also. So this is the thing. And very few people think, okay, one semester is too much. Everyone wants to use AI and learn quickly. Okay, learn in 1 day, 2 days, and use it, and okay, then move on. And most of people are okay, they know how to use the programming skills, but not the hardcore developers. So I also fall in that bucket. So I know how to use the programming for my application, maybe from asking from ChatGPT, okay, write me the code for this. So this is clear from the survey as well. And Python, as always, the winner for the favorite programming language. And next by R, because it's very simple. And next one. Yes, and these are the responses we received for like what are the topics that people want to be introduced in curriculum for GeoAI. Like starting with the basics, because people want to understand what's going inside the black box, how it is working, and how it is being used and how it works. And yeah, this is a good sign that okay, people want to learn and people think that it can be beneficial in their employability or maybe in their research or in their career. And this is the overview of the participants, like from different background, different level of studies from different regions around the world. So as the sample size grows, we have more analytics. And at the end, I would like to promote ISPRSC. So we have over 7,000 members on Facebook group and more than 1,800 followers on Twitter and 800 members annually. Because and you can scan this QR code or you can just simply Google ISPRS Student Consortium. And the registration is complimentary. You don't need to pay anything, and you just need to fill up very basic details. And we will just overview your details because just to check if you are not using AI to just put up the details. And post verification, you will receive a certificate from ISPRSC. And on every 1st January, you will receive an email to renew the membership. The thank you slide.
So if I understood correctly, you have to be less than 35 years old.
Yes.
So I don't know if I can be accepted as a.
Try hard, yes.
Yeah, okay, yes, it's true, it's true. Okay, now, thank you so much. Thank you also for the survey that yes, if you then can share with us the survey, I believe that it can be of interest of all of us. Thank you so much because we spoke about the survey, but you didn't tell me that you did the survey in the end. It's a surprise.
Yeah.
I wasn't expecting. So very
Yeah.
good. Super good. Thank you so much. Thank
And
you.
if you have any questions or if you want to like organize an event, you can always reach out to us.
Yeah.
We can we have the Zoom account like which can host up to 500 participants. So it's always welcome, and we are always there to support. Yeah, thank you so much for listening and staying awake.